Yes, sir, we are good to go.
We are live now.
Yes, it's live now, sir.
We can start now.
Good evening, friends. So today we are going to have a very interesting webinar on energy sources in minimally invasive gynecology. Gynecological surgery has undergone a transformation with the advent of energy sources, but along with it, the risk to the patients and to the surgeons have also increased. It is very imperative for us to understand the essence or the functioning of these devices so that we can use it very judiciously for our patients. Okay, so today IAGE and Dr. Pandit Palaskar, we are telecasting this webinar from the IAGE website. Okay, we have Emcure as our service providers. And now Dr. Pandit Palaskar shall address the event.
Hi, good evening, everybody. First of all, thank you all the organizers for this very interesting webinar. Dr. Ameya Padmavara has taken a lot of efforts to organize this webinar, and we have our media partner Emcure with us, and we are very happy to have all these organizers with us. Friends, as Ameya has said, after imaging system for endoscopy, we need two very important tools. One is we need very good camera system, and other is we need very good energy sources. So energy sources plays very important role in the better outcome of the surgery in endoscopic surgery. If you have very good energy source and if you use it very wisely, the outcome will be very nice. And if you don't have good energy source or you don't use the good energy source in proper way, otherwise also you land in complications, because most of the complications, whether it is ureteric injury, bladder injury, fistulas, intestinal injury, delayed intestinal injuries, they are caused by the improper use or lateral spread of the energy from the energy sources. So today, the aim of this webinar was is to have our members, the delegates, the proper idea which energy source to use, and for that we require proper understanding of the mechanism, how these energy sources they work. So we have stalwart faculties who are expert in this field, and I'm sure all our delegates, they will get the clear idea what is the mechanism of action of these energy sources, which energy source to be used for which surgery, and ultimately it is the man behind the machine. We should not be taken away that I have this best energy source and now I am free from complications. Ultimately, it is the man behind the machine. We have to use these energy sources wisely, and at the end of the webinar, all our delegates will have the clear idea which one to choose. And so we'll start the webinar now. Thank you so much. We'll go ahead.
Thank you, Dr. Pandit, for the kind introduction. And the first speaker is going to be Dr. Shinjini Pandey. She is a consultant and an endoscopic surgeon at Nalini Specialty Hospital, Goregaon, Mumbai. And she's an ace endoscopic surgeon, and she's going to throw light on the principles of electrosurgery and its application in minimally invasive gynecology. Dr. Shinjini, you can start your presentation.
Yes, sir. Am I audible properly, sir?
Yes.
Okay, at the outset, I want to thank Dr. Pandit sir, Kalyan sir, Ameya sir for making this possible, and I will start now. So I am given the first part, basically, which means that I should be dealing with the physics or the principles of electrosurgery, and I will be covering the monopolar circuit part of the electrosurgery. So just a few quick facts. Basically, this is US data. And if you see US data, it shows that there are around 40,000 burns reported every year in the OR. And out of these, 70% are not recognized intraoperatively. This is a big time cause or could be cause of litigation. So we must all understand electrosurgery. And what are the targets of my part of the talk? Basically, to understand the correct terminology. It is very important to speak the right words, because it is only when you speak the right words that you have understood the science. I will be dealing with how the generators work, your electrosurgical unit, especially with monopolar circuits. And also we will be seeing how tissue effects with monopolar are created. So if you are seeing the left part of your screen, these are the correct words. And on the right part, the ones with the red are the ones that you should not be using. So basically there is nothing called as the cautery or the cautery machine. Cautery basically means a hot iron rod. The correct word to use is the electrosurgical unit or the generator. The current that we are using is radio frequency current. There is no grounding pad. Nowadays, electricity is not grounded back. It is returned back to the electrosurgical unit. And therefore, the electrode which returns this back should be called as the dispersive electrode. There is no energy like monopolar or bipolar. All is same energy which is used. It is the electromagnetic part of the RF spectrum. But you can change the circuit to create certain effects. So the circuit can be bipolar and monopolar, and the instruments used in the circuits can be bipolar and monopolar. We will see otherwise in detail later on. So cautery is just passive transfer of heat. Now, so electrocautery is not same as electrosurgery. What is electrosurgery? Electrosurgery is when you're using the electricity and its effects, you are able to modulate it to your surgical need on the tissue without causing a complication. So that is what is electrosurgery. Now, electrosurgery has a very, very interesting background. Basically, there was this great scientist by the name of Louis Galvani. We have learned him in 10th class physics. And he was experimenting on the leg of frog muscle. So the muscle, the frog muscle tissue of the leg. And he found that when he applied electric current of certain frequencies, the muscle would contract. Now, his colleague was a scientist called as Morton. He discovered that if they kept on increasing the frequency of this current, there was a time, or there was a particular frequency over which the neuromuscular stimulation stopped. And therefore, the potential or the hazardous potential of electrocution or cardiac decompensation was bypassed, and this frequency was 100 kilohertz. So basically, जो power station से power आती है, that is at 60 hertz. And your electrosurgical unit or the machine that you're using, the generator, has only one major function: to convert this 60 hertz, which is coming from the plug point, to something which is more than 300 kilohertz. Normally, जो आजकल के generators and the generators that we are using work in and around 500 to 550 kilohertz. Now, this frequency of 500, 550 basically corresponds to the waves coming from the FM radio or the AM radio station. And therefore, all these electrosurgical wavelength is given the word RF current. So basically, RF ka R is radio frequency, which is basically a misnomer. Misnomer matlab it is the same frequency that is coming from the radio station. So it is, you will read in papers or articles, everywhere they will write RF current. Okay. Now, let's see how electricity behaves. So basically, to understand electricity, you have to think about it as water. Now, water, if you see the left part of this diagram, this is a tank full of water, and water is falling from this tap. And if I want to increase the amount of water falling on the ground, the first thing I can do is to raise the tank at a greater height. Now, if I raise the tank to a greater height, with the same diameter of the tap, I get more water on the floor. Now, basically, raising the height of the tank actually corresponds to raising the voltage of your generator, which basically corresponds to raising the wattage, because जो generator पर depict होता है वो watts होता है. Wattage is directly proportional to voltage. So when you are increasing 30 watts per car, 40 watts per car, so you are increasing the voltage of the generator, which basically means you are raising the water level of the tank. Now, the other important factor is the diameter of the pipe from which the water is falling. So with the same heighted tank, if I reduce the diameter of the pipe, I will get a lesser amount of water falling down, which basically means if I reduce the diameter of the pipe, which basically means I've increased the resistance of water flow coming out. Now, tissue resistance, therefore, or intuitive tissue resistance is a very, very important part in modifying tissue effects in electrosurgery. And every tissue has a different resistance to the flow of electrons. And basically, if you want to understand it in one line, this basically means ki pani kitna hai, how much is the water content of the tissue. If the tissue is having a lot of blood, if it is well vascularized, there is more water, and this will transmit electricity more easily. So hair, scarred tissue, external burn scar, redo endometriosis, previous myomectomy scars, you will see that your pencil or your monopolar instrument will not work very efficiently. So this is what is meant by intuitive tissue resistance. This is one of the factors which will modify the final effect that is seen to the surgical eye. Now, what is a monopolar circuit? Very simple. The electrosurgical units say the connection goes out, and this is the active electrode on which the surgeon is operating. Then the return or the dispersal of the current is done via the dispersive electrode, which has a 10,000-fold more surface area than the surface area of the tip of the electrode here. And by this means, then it is returned back to the electrosurgical unit. Now you have to understand by default, therefore, the monopolar circuit could be prone to hazards because actually the current passes through a large part of the patient body before returning back. If you just see the bipolar, this I am not covering, but nevertheless, in order to compare, you can see that the two prongs act as the active versus the dispersive electrode, and only the tissue that you're catching in between is a part of the complete circuit. Therefore, by default, bipolar circuits are way more safer. Now, this is the front face of your electrosurgical unit. This is the plug point. This is at 60 Hertz coming from the powerhouse. What does this machine do? Basically, the basic function is conversion of low frequency 60 Hertz to RF output. Then what is the second thing that you can do? Now, this machine has a yellow pedal and a blue pedal, or if you're using the pencil, a yellow button and a blue button. So yellow by code of international nomenclature means pure cut, and blue means coagulation. Now, these are the biggest misconceptions which are made in electrosurgical science, because if someone tells you the word cut, by default, you think that this current is cutting. So this could be a very bloody current or a very hazardous current. And coag, the word coag looks so safe because it is very hemostatic in appearance, but it is totally ulta. It is vice versa. The cutting current is actually the safest waveform that can be used, and this I will explain now in the next few minutes. So the electrosurgical unit gives you the option of choosing the pure cut, meaning yellow, or the pure blue, meaning the coag. Now, there is this option wherein you can set the wattage meaning voltage. Okay. Now, coming back to this slide. So basically, don't look at the blends here. Just see the left extreme and the right extreme. The left extreme is the pure cut waveform. So when you are pushing the yellow of your monopolar pencil, then what are you doing? You are using a voltage which is very low, and the current is on for 100% of the time cycle. So suppose I set a wattage of 100 watts, then it is going at 10 volts for 10 seconds. So 10 into 10 makes 100. However, if I'm using the blue pedal and I've set the same wattage, like 100 watts, but this you have to understand, this is off for maximum part of the time cycle. This current is on only for a minimum part, maybe 1 second. So in order to reach 100, the voltage has to spike to 100 into 1 equal to 100. Vis-a-vis here, 10 into 10 equals 100. Now the root cause of all hazards is the high voltage. So any current which is on a low voltage and is being used for low voltage for most of the time cycle will be a more hemostatic current, a more safer current, less prone to damage. Okay, so this is what is the first message of the day. Now some electrosurgical units have blends. Now blend is again a misnomer. Blend का ये मतलब नहीं है कि pure cut और coax को कुछ join करके blend कर दिया. Basically this is when you alter the time cycle of the pure cut waveform. Now pure cut it is on for 100% of the time cycle. In blend you give little gaps, and so in order to achieve let's say 100 watts, because the time on is less now, so you reach a higher voltage. Blend 2 a little more higher voltage. Blend 3 highest voltage amongst the cuts, but little less than coax. Okay. So let's see this. For example, this is the setting of a is my video running? So here you have set the cut current. Now you can see cut, very low waveform. Here we have set the voltage wattage at 30 and it is running for 100% time cycle. Now same if you run at 100 pure cut, again you can see the peak voltage achieved is less than 2000 volts. But same thing if you see at around for a coax current, for 50 wattage, you will see that the voltage already spikes to 4000 volts. Now, therefore, please remember that whenever you are pressing the blue pedal on your monopolar circuit, on your monopolar pencil, you are sparking and raising the voltage to thousands of volts. Sometimes this current can be very hazardous because this acts like lightning. Lightning comes from the sky and crosses the air, which is the highest resistance tissue, just because it has very, very high voltage and can cause tremendous damage. So this is more so when we open activate a circuit. What is open activation? Suppose I use my monopolar drilling needle in order to do a PCOD drilling, and I press the blue pedal before actually reaching the ovary. So the way from my port, my pedal is on, but my monopolar pencil is moving with the pedal pressed on, and this is all open activation in the air environment inside, and therefore the current gets leaked into the atmosphere and can cause sparking and burns. You can compare this here. The pure cut is a white cut, and you can see the coax has a lot of charring or a high voltage effect. Now again, so abhi tak humne dekha, like we saw that what were the two fundamental factors which tell us what the final effect on the tissue will be. The first was what is the wattage setting that we are using on the generator. The higher the wattage, the higher the voltage, and therefore higher the effect, but higher the side effect. The second is whether we are using the yellow pedal vis-a-vis the blue pedal being much, much more charry. Okay. Now the third is what is the surface area of the electrode that you are using with the same type of wattage or the waveform. So here you can see when we use the tip of the electrode with the same pure cutting current, it cuts. But with the same yellow pedal, if I turn by 90 degrees and I use a higher surface area of the electrode, there is no cutting effect. It is acting like a hemostatic or a coagulatory effect. Again, you turn the blade. Again, now the pedals are the same, wattage is the same, but tissue effect is different. Why? Because of the current density is changed. Again, now this is to verify your terminology. Now you can see, look at the graph. Now this is on for 100% time cycle. Therefore, by default, the surgeon has pressed the yellow pedal, and he is using a sharp tip electrode and is not touching the tissue directly. So this will cause a linear cut on the tissue, and this is known as vaporization. Same yellow pedal, because the duty cycle is on for 100% time, but a flat electrode and now touching the tissue. You can see it forms a nice coagulum of proteins here, and this causes perfect coagulation. Same, we come to the dangerous blue current. Now blue current on a ball electrode away from the tissue, high sparking and superficial coagulation, which is the technical word is fulguration. This is useful in certain areas of the body. For example, if a general surgeon is doing lap cholecystectomy and the base of the liver starts oozing. So this is a wide area, low ooze. this can be best held with fulguration. Now, let's come to this video. So now just imagine that you were doing an open surgery or even a lap surgery for that matter, and you encounter a bleeder. Now, when you encounter a bleeder, the first thing that you will do, at least in open surgery, is that you will catch it with your artery forceps and you will ask your assistant to buzz you with the monopolar pencil. Now, if you see everyday surgery and the use of everyday surgery, all of us actually press the blue, because हमको क्या लगता है blue press करेंगे because the word coag, no? So we feel that it will be immediately hemostatic. In actuality, it is totally opposite. If you press the yellow, you are actually sending in low voltage and continuous current, and the coagulum that creates in the vessel wall is uniform. It is like slow heating of the toast on the tawa. So if you heat the toast and on a slow flame, the whole toast becomes crisp. However, if you heat the toast on a very high flame, the surface becomes of the roti or the tawa of the bread becomes blackish, but when you bite inside, the inner core is soft. Similarly, if you see here, the surgeon is using the yellow pedal and is sending low energy, low voltage, but for full time cycle, and this is the white seal that develops. Now, if the surgeon presses the blue pedal, this is what happens. There is uneven coagulum and there is an incomplete seal. Now, you will say that we have all our life used the blue pedal to buzz the surgeon's artery forceps. But see, you have already, all these vessels are basically quite small, the ones that bleed on the rectus and all. Many times when you leave, it bleeds again and again, you have to touch. Try using the yellow, but be patient. Use it for a longer time. It's a perfect seal. Now, these are the same effects that we are showing on a video here. You can see that the surgeon's finger is on the yellow, and see the linear. This is vaporization. This was near touch and it comes as a clean cut. Now notice that in the next few seconds, his now fingertip is on the blue, this thing, and this is, see the sparking. You can see like how Diwali mein Fulzhadi ke sparks sparkle out. So this is the sparking. Now with the same electrode, we are trying to show coagulation. So now on a yellow pencil, see now for the same time period, 1, 2, 3, 4, 5, 6, 7, 8, 9. Same seconds, this is with yellow. Now the same effect you are seeing with the blue button. Now you will see 1, 2, 3, same time period, same wattage on the generator. See the amount of sparks that are flying on the sky. And this is coagulation. Externally, it looks the same. But when you cut the tissue out to see what is the depth of penetration, you will find once, now see the demonstrator here is cutting the orange. And once you cut the depth, you will see that the yellow wala waveform actually penetrated deeply to coagulate the vessel completely, while you can see that the other one sparked all over in the air. But can you see the depth of penetration? It is very, very less. So this is how you should understand electrosurgery, and this is how the blue current, the blue mode works. A last word about injuries. So all injuries are basically voltage related. I hope that this is clear by this time. And this is a diversion injury. What is a diversion injury? Now, suppose you don't place your dispersive electrode in the proper format, then the current will seek alternative routes. So this was created, for example, the leg must have been against the metal stirrup, and this energy used the path of least resistance and followed the ground from there. So this is a third-degree burn on the knee. Similarly, you have this nowadays, the modern electrosurgical units have the return electrodes which look like this. So there is a split. These are known as split electrodes, and this is known as return electrode monitoring system, REM system. तो होता क्या है कि there is a split here and there is one electrode, micro electrode here and another here, and there is a small mini circuit here. So unless the whole pad is in contact and the mini circuit is working, the machine will not work. So if this one part starts stripping off or is not well applied, for example, you will get a red error onto the machine. So nowadays we have these automatic monitoring systems which are very safe. Now coming to insulation failure. So many of us do PCO drilling, for example. So we should always be checking the insulating surface. And you remember that even if there is a small hole, it can, and you are using the blue pedal and you are open activating, means you've pressed the pedal but not yet touched the tissue. This small hole acts as the highest density because surface area is less. You are using the blue pedal, so voltage is around 4000 volts and you have not yet touched the tissue, so circuit is not complete. Basically you are creating lightning inside the patient's abdomen, and this lightning can just stray off behind and can cause a burn. So please remember, if you're using the blue pedal, please do not open activate the circuit. Please check your insulations correctly. Now, this is just a demonstration to show you that even if the wire is well insulated, now this is a force effects machine in which the wire is insulated around this bulb, and this is how the radio frequency on a blue current can leak. So even with no damage and perfect insulation, you will see that the bulb kind of lights up. And this is similar to what happens when sometimes we take towel clips and wind them around with well-insulated wires. It is not that your wire is having an insulation leak, but charge accumulates due to RF leakage, especially if you are using the blue pedal. And I have seen open surgeries completely done, except for skin opening, completely done with the blue pencil. So now you can see that this discharges out and may create a burn on the thigh or on the skin, wherein you are. So never use metal, never wind insulating wires of monopolar circuits around metal instruments. Now, last word. So what are other injuries that can happen in monopolar circuits? So this is something called as direct coupling. Now, basically direct coupling is utilized in surgery also. When you have a bleeder and you hold it with an artery forceps and आप आपके assistant को कहते हो कि touch कर, basically you are using the direct coupling to activate the thermal energy to cause hemostasis. But the same direct coupling can create a problem. For example, if this is the laparoscope, you have the hook here and your field of view is here, you don't know piche is that bowel loop, because metal on metal conduction is direct. This may dissipate on this bowel loop. So you have to know that certain injuries are possible via direct coupling also. There is another phenomena which is known as capacitative coupling. Now, what is capacitative coupling? Capacitance is a phenomena of physics in which what happens is, suppose you have a conducting instrument and another conducting instrument which are separated by an insulating system. Then this is the ability of charge to go via the insulation gap and collect on the other metal or part of the conductor, and from here it may get discharged. Now, how does it affect us in surgery? Normally, this does not happen because the metal, even if we are using metal trocars, the electricity goes via path of least resistance, which is through your dispersive electrode. But if you are open activating the circuit, if you are using very high voltage, you are setting the wattage to 60, 70, then there is a possibility of this happening. Another major possibility of capacitative coupling injury is, suppose आप Apple trocar use कर रहे हो. अब Apple trocar जो है is a plastic device which is as such very high resistance, insulator जैसा है. But Apple trocar के अंदर आपने 5 mm Apple trocar यूज किया, उसके अंदर आपने reducer डाल दिया 5 to 3 का, आप ट्यूबोप्लास्टी कर रहे हो, just imagine, and you put a 5 to 3 reducer of a metal inside, and the metal reducer length is longer than the apple, and then you put your monopolar pencil. So what happens is charge from here goes on to the reducer and accumulates but cannot get dissipated out because the skin contact is with the plastic apple trocar. Now, this will then definitely come on your intestine. So whenever you're using reducing devices, either it should be plastic on plastic or it should be metal on metal. So that is how you can prevent. And also the good ways to prevent is always using the yellow energy wherever the yellow pedals can be used. If you are using the blue, please do not open activate the circuit. If you are using the blue pedals frequently, please see that your trocar on trocar systems are of the same types and your dispersive electrodes are well applied and you are using the REM monitoring systems. Again, single port surgery that was much in fame a few years back. This had a very, very large incidence of every type of injury, not just capacitative coupling. And this was high risk. And basically, this is the message of the day. So the final message is tissue effect as seen by a surgical eye is a play of many, many factors. When we are using monopolar circuits, the first factor that you should decide is whether I need a blue pedal or I need a yellow pedal. That is point number one. Point number two is kitna wattage select karu. Use the minimum required wattage. Do not just because you don't see an effect, it's probably because it's the time you've spent on the tissue is less. So first, choose the wattage intelligently. Third is understand tissue resistance. Drier the tissue, the more time it will take. Tissue resistance can also be changed by giving traction to the tissue. The thinner the tissue, ask your assistants. Suppose you want to pull, if you pull the UV fold and make it very thin, it cuts like butter. Okay, why? Because thinner the tissue, lesser the resistance. So the effects of tissue can be modulated by altering the traction on the tissue. Fourth is the time you've spent. Suppose you run your pencil fast, you will get a cutting effect. You stay on the tissue long, you will get a white zone, which means it's getting coagulated. Use the surface area intelligently. You use the pointer, you get a cutting. You use the flat, you get a coag. Finally, when using fulguration or using the blue pedal, be very cautious of surrounding structures. Fulguration is not for anywhere near the ureter. It may be okay for the liver bed. Okay, so these are the final points that highlight the use of monopolar circuits. With that, thank you.
That was a very interesting narration by you, Dr. Shinjini.
Thank
And
you,
it is going to be very useful for all the members when they choose their electrosurgical generator, which is unreplaceable component of every endoscopic surgery. Of course, the points which you highlighted about the nomenclature, the intuitive tissue resistance, the concept of wattage and the surface area of the contact electrode were useful, and an insight into the tissue resistance helps you use it patiently and judiciously. There's a revival of use of monopolar energy in robotic surgery as well.
Yes.
So it is very, very important that we understand this modality in detail.
Even in open surgery, sir, it is rampantly used. So the correct buttons to be used should be tried.
Yes.
Yeah.
And please wait back for the discussion at the end of the session. And we go to the next speaker. The next speaker is Dr. Suyash Nawal. Dr. Suyash Nawal is from Jalgaon, and he's a pioneer of V-Notes surgery and eminent endoscopic surgeon attached to several hospitals. And he's going to throw light on the concept of bipolar energy sources and the so-called tissue sealer devices. Dr. Suyash, you can start with your presentation.
Thank you so much. Is it possible to play the video that you have? Because my internet is a bit dodgy.
We can definitely do that. So Dr. Suyash has sent me the video. I shall share it. Just give me a minute.
Yeah. Just optimize it for video and sound while you share. I have kept the focus of my presentation on advanced bipolar and vessel sealers because in 20 minutes I could do justice to that. I guess with Shinjini ma'am's presentation, everyone is well versed with the basics now.
Okay, now everybody can see the screen.
Not yet.
Yeah, now we can see your screen.
Yeah, just a minute. Okay, can you see now?
Yeah.
Yeah.
Okay, I'm playing the video.
Hello, everyone. First of all, thank you, IAGV, for giving me the opportunity to present this topic of advanced bipolar and vessel sealers. This is my disclosure. I have no conflict of interest. So we'll first begin with what is the basis of advanced bipolars. The main difference between our usual bipolars and the advanced bipolars is that advanced bipolars use adaptive tissue technology. Now, what is adaptive tissue technology? It is basically using an automated tissue feedback response system. What does that mean? That is, there is a computerized program in the generator and the processor which senses the impedance and measures the impedance constantly, continuously, and readjusts the voltage and current according to the impedance, and the same impedance measurement will tell you whether the vessel has completely sealed or not when the current transfer has ended. Now, the delivery of the electrical transfer can be pulsed or continuous, but the main feature of advanced bipolar is this computer controlled high frequency adjustment of voltage and current. Now, what does vessel sealing mean? What is the mechanism of vessel sealing? Now, if you go to the basics of vessel sealing, it means that it is a combination of the pressure applied by the jaws of the bipolar device plus energy. And what this results is that, and of course, when you are using an advanced bipolar, there is this tissue impedance feedback, which is at least more than 3000 times per second. Okay, it can be more also. This is the basic definition. And this leads to denaturation of collagen and elastin, resulting in the complete fusion of the vessel walls, so that two vessel walls are also coapted and interlinking proteins are denatured and combined together to form a single seal. And this unique combination of pressure and energy is used to fuse the vessels and lymphatics, including up to vessels up to 7 millimeter diameter tissue bundles, and there is no use of sutures, staples, or clips in these devices. Okay, so this is the vessel sealing mechanism. Now, just to give you an example how LigaSure works is what they have described is that electrical energy is pulsatile, reducing the thermal spread up to 1 millimeter. That is what the official website says. Impedance feedback is there, and this keeps changing as the device advances. The impedance feedback rate increases. Seal cycle is 2 to 4 seconds, and it has one more feature, that is retractile blade for cutting. This can be feature of, and this is how with the heat and pressure the collagen is denatured and elastin is denatured and a vessel seal is formed. So what is advanced bipolar? It is vessel sealing technology plus inbuilt cutting mechanism. No need of additional instrument cutting for cutting, and the generator indicates the completion of seal cycle with the impedance feedback loop, and the surgeon can then proceed with cutting. Now, here are just examples of what all devices are available. You can have any of these devices, and I think most of these devices are available in India. LigaSure is from Medtronic, NSeal is from J&J, Gyrus is from Olympus, Marcel is from KLS Martin, Voyant is from Applied Medical, CoolSeal is from Hologic, LigaPro is by Winglobe, I think it's an Indian company, and Thunderbeat is again from Olympus. Okay, now there are various devices. You can choose any one of them, and they qualify more or less in the definition of advanced bipolar. Just to share as an example how this device works, what is the sequence of working with, let's say, LigaSure, you grasp the tissue to seal with proper pressure, activate the energy, and continue pressing. And this continuation of pressing is helped by a lock system, which is inbuilt. Generator automatically controls the energy delivery. Wait for the double beep end tone signaling for seal complete. Activate the cutting blade after that to divide the tissue, and then open the jaws to release. So this is what is the usual sequence goes. Okay, and there can be variations to this depending on what type of device, which company device you are using. But the most important thing is what are the usage tips that company has given, and also some usage tips which I will give you from personal experience. One is no isolation of vascular structures is needed. This is what the company says, but I think some degree of skeletonization is better. That is my opinion. Retaining some amount of adventitia above the vessels is important to gain more collagen for a better seal. Now, avoid tension on the tissues when sealing, because that will change the dynamics of the tissue, and then that is not the ideal way to seal. So that is very important. Recognize and re-grasp the alerts with 4 short beeps, and keep the electrodes clean. You can use moist gauze. This is important for proper energy delivery, and it also helps in preventing sticking, because if there is some blood, which is charred blood, which is there on the device, then it may not function in an optimal way. And do not overfill the jaw. That is, your grasp should be less than the length of the jaw, grasp of the tissue. Okay, that is what is meaning. What is the meaning of not overfilling the jaws? Okay. Now, this is just an animation of how advanced bipolar works. Now, for example, here we are seeing LigaSure. Your first thing is you clamp the tissue with, you apply the pressure, you maintain the pressure, and then the generator will deliver the energy, of course, with the signal of the surgeon. And then when the beeps come around of vessel seal, that is when you cut the tissue. Same goes with this device and seal. Now, all these companies will use different terms to describe their working mechanism, but in the end, it is the same thing, that it is a combination of pressure and energy and an active feedback loop giving information that the tissue has been sealed and all the proteins have been denatured and the vessel has been sealed. Okay, so the basic functioning and the basic idea is same. Only now there are these newer devices, for example, like Thunderbeat, which use combination of 2 technologies, that is ultrasonic, which I think will be presented in detail in the next presentation, and the vessel sealing technology. So this particular device has got a combination and simultaneous use of these 2 technologies, ultrasonic as well as vessel sealing bipolar technology. So that is very interesting, and it can have, I don't have any personal experience of use of Thunderbeat, but I think those who have can highlight more on that during discussion. Now, this is how I use advanced bipolar. I do a lot of vaginal node surgeries, which is endoscopic vaginal surgeries, and particularly advanced bipolars with inbuilt cutting mechanism are very helpful in such surgeries, because you don't have to exchange instruments And with one single device, you can complete your entire surgery and it is especially very good for hysterectomy. Like you can see here, you can also observe all the pedicles that I have sealed, and you can visually understand the quality of seal and the way you are using the device. All you have to do is uh, grasp the tissue, don't overfill the jaw, apply pressure, wait for the seal cycle, and then cut. And just keep away from all the important structures. So the safety margin is very important. Always have more safety margin than what the company claims. That is the basic idea. Now, there are different terms which different companies will use, and the basic effect is very synonymous. Okay, like for example, Olympus, Gyrus, PK, they will explain you in terms of vapor. A vapor zone is formed, and the current passes around the vapor zone, and vapor zone collapses, and the tissue sealing occurs. So many companies will come out with different terms, but these are basically synonymous. And if you see the end effect on the tissue, it is basically the same thing. That is a combination of pressure and energy. And the basic functioning of advanced bipolar is by utilization of impedance measurement to understand the seal has completed or not. And that is the completion of seal cycle. So don't get confused with various terminologies that companies use. But some companies may have definitely different things. They bring something different on the table. For example, Thunderbeat, it is a single device with two technologies. Now, ultrasonic is something which is called the frictional heat generation because of high oscillations of the ultrasonic probe. And plus this, I think Dr. Sanket sir will talk more about that in detail in next presentation. I will not focus on that. Plus, it is in Thunderbeat, you combine it with vessel sealing. And in this diagram, you can see that how ultrasonic probe is also a bipolar electrode, and how both these technologies are fused together and they are used simultaneously. And there is the advantage is that there is no cutting blade required. Probably that increases the life of the device. And that is the reason probably why this device has been marketed as a reusable probe, if I'm not wrong. And one more thing which studies have highlighted is that Thunderbeat has, it seems, a high burst pressure compared to other devices. That's what some of the studies say. And plus, every company has their own unique feature in terms of jaw design, with more grip and these things. So you can personally evaluate what is good for you. One may not be necessarily superior to other, but it depends on your situation and your hospital setting, your cost analysis, and any device may be better for you. That is, so my idea is to lay out information about all the devices to you. For example, here you have comparison between Harmonic, LigaSure, and Thunderbeat. Now, some of these charts may be older. These devices keep upgrading and newer generations keep coming. But basically, all these devices are good enough for 5 millimeter. Some companies may claim 7 millimeter vessels also, they can seal well. And that keeps changing with generation. For example, newer generation of Harmonic can seal 7 millimeter probably. Comparison between the cutting speed, Thunderbeat claims to be the highest, fastest cutting effect, and burst pressure is also maximum with Thunderbeat. But all said and done, all these burst pressure, the most important thing is that if the burst pressure is 3 times more than systolic blood pressure, normal systolic blood pressure, that is, if it is more than 360 millimeters of mercury, it is more than enough. Okay, so anything more than 360 is one and the same thing. So don't decide according to that. Okay, so hemostasis and action, thermal spread, all these are comparative parameters. More or less, all the devices claim to have lateral spread between 1 millimeter to 2 millimeter. And of course, then ergonomic is something which depends on the surgeon experience. You may find one device more ergonomic than other. You might be doing some kind of surgeries which is more suitable for one device than the other. So it depends on your scenario, your practice, the kind of surgeries that you do, the cost at which you do. So all these things have to be taken into account whenever you decide to buy an advanced bipolar or vessel sealing device. And also be wary that different studies highlight different things. One study will say that LigaSure has less thermal spread than harmonic, and there will be other study which will tell you that harmonic scalpel has least thermal spread, for example this one over here. And in terms of burst pressure, LigaSure is highest rated compared to others. And then also there are parameters like smoke and visibility. The least amount of smoke is by harmonic scalpel. These all things can be debated. Like I think ultrasonic energy produces a different kind of a dust, which is not exactly smoke, but I think they are very tiny tissue freckles. So that also interferes with visibility, and it is not just always about smoke. So this is a very interesting study, which I think is very important pertaining to Indian scenario and many countries where these kind of advanced bipolars, which are marketed officially as a single-use device or as a disposable device, but they are used as reusable device. We know that there is an off-label use, reuse with sterilization, of course. So this particular study looked into what happens when you reuse and re-sterilize these devices in terms of their performance, and they compared LigaSure and Kaimin to Marseille. Marseille is a reusable advanced bipolar system. So they found out, the good news is that they found out that they achieved burst pressure comparable to those produced by the reusable Marseille. But it is important to note that the number of cycles they were used was only 5. So you have to understand all these things, because with reuse, every company will tell you that the coating of the device, the nano coating of the device will go down, the performance of the tissue of the device will go down. It can interfere with the impedance feedback loop measurement, and so forth and so on. So you have to be aware of these things if you are someone who is reusing and re-sterilizing these devices. It is very important to understand the concept of vessel seal strength, because this is what you will be looking at. Ultimately, this is what you want when you are choosing to use a vessel sealer. It depends on many factors: what type of vessel it is, whether it is artery or vein. Arteries have a better seal than vein. Vessel wall thickness, the less than 5 millimeter vessels have a better sealing. Vessel composition, how much is the percentage of elastin, how much is the collagen, for example. It has been shown in studies that with reduction in the elastin content, there is an increase in the seal strength. Okay. And then blood pressure has also the role. The distance from the vessel origin from bifurcation has a role. The more you go away from the bifurcation or origin, the seal strength increases. Now, this is all have been studied in various, mainly ex vivo models. So you have to understand that the situations inside the body in vivo may be slightly different. But the good thing is that when considering minimum threshold for the successful seal, it was found that vessels of less than 5 millimeter in outer diameter were shown to have same kind of seal strength irrespective of vessel morphology. So for less than 5 millimeter, you don't have to think about all these variables. For more than 5 millimeter, you have to understand what type of vessel it is, what is the thickness, what is the outer diameter, whether it is artery, whether it is vein. For example, here you can see that as the elastin content decreases, the vessel's seal strength goes on decreasing. Okay, goes on increasing. So with more the collagen, less the elastin, better is the vessel seal. So that explains the difference between vessel seal strength between artery and a vein. Okay. Most important thing that everyone is concerned about while using any kind of energy device is lateral thermal spread. And that is not something that you can get away even when you are using an advanced bipolar. Okay. So what are the parameters on which lateral thermal spread depends on is, again, this has been studied and there can be various variables to it. Most important thing is that you have to understand what device technology you are using, what kind of insulation materials they have, what is the quality of the device, again, whether you are using it for the first time or whether you are reusing it, what is the tissue composition that you are dealing with, what is the percentage of elastin in this tissue, whether it is artery or vein, what is the duration of seal cycle, because one particular company may have a longer seal cycle than other. That is just because of the way they deliver energy, the way they deliver voltage and current, the way they measure impedance feedback. It all depends on that, and that will ultimately determine what is the duration of seal cycle. That may have an effect on the level of temperature, and that may have the effect on the thermal spread. So this has been studied in ex vivo models. Like here they studied marsil, and they measured what is the critical zone. The critical zone is something where the temperature is more than 50 degrees Celsius, which may cause irreversible thermal damage. So anything with up to 50, more than 50 degrees Celsius is a thermal spread that can damage tissues irreversibly. So coming to new updates and newer devices, so many companies are trying to improve these variables and offer you newer ways and more technologies. Like for example, here is an example of Hologic Cool Seal, which is the first device that claims to have less than 1 millimeter thermal spread. Now, of course, all these things are according to what company website says, and you have to understand it may vary depending on what tissue that you use it on. Another example is Buoyant from Applied Medical, which says it has the fastest seal cycle, less than 1 second. Okay, I'm telling you, giving you all these information that every company has its own USP, every device will have its own advantage and may have its own disadvantage as well. The more you research into it, the more you know. There is also, I think this is the only reusable advanced bipolar which is available in Indian market. So Marsil, you should know about this. I think this is the device from Bissinger called eCut, and it has a different mechanism of working compared to the other advanced bipolars. It does not have a cutting blade. So the way they have designed the blade is in such a way that it causes coaptation of the vessel walls and vessel sealing and cutting effect at the same time. Now, I'm not sure whether this could be included in the definition of advanced bipolar. And there are similar devices other in India markets called shearers, which have the similar working mechanism, but I'm not sure whether we can include them in the definition of advanced bipolar, because if they are not using the feedback, computerized and controlled feedback loop and impedance measurement to adjust the voltage and current that is delivered to seal the vessels, whether we should include them in advanced bipolar is not, can be a matter of debate. Okay. So now in the end, I want to conclude with 9 golden tips from my personal experience. This is just a practical guideline. What I have experienced is that vessel sealers are highly effective for vessels up to 5 millimeter outer diameter. You can easily get away with vessel sealing devices with these size vessels. They are moderate to highly effective for vessels up to 7 millimeter outer diameter. Okay, so for 7 millimeter, you should be considerate of what tissues you are dealing with, what type of device, what energy. So all these things are important, and you can increase your performance by sealing at multiple places. So that these are the surgical hacks that you can use, that instead of sealing just at one place, you can seal the vessel at 2 or 3 places. But for that, you need to have a very good dissection. You need to skeletonize in a nice way, not over skeletonize, and also lateralize all the important structures like ureter and bowel away. For more than 7 millimeter size, I would suggest that you should seriously consider suturing, because if you are doing advanced laparoscopy, there is no getting away with suturing. Veins can be difficult to seal. It is the attribute of its tissue composition. So my tip is that don't skeletonize the vein completely. Maintain the surrounding adventitia to gain more collagen in the seal. That will help you. Some degree and not complete skeletonization of arteries help in good seal. Like, I do not agree that you don't have to skeletonize at all. Some degree of dissection is important to identify the vessel, and then keep some adventitia over it for gaining more collagen. Charred tissue, necrosed tissue, or when there is blood, bleeding interfering with your and on that you are coagulating, that will interfere with the impedance feedback. It will lead to poor sealing, and it will lead to more bleeding, and then you will ultimately land up in more thermal damage. So whenever there is such a situation, you have to go back to basic surgical principles, that you have to first control the bleeding, apply pressure, identify where the bleeding is, identify if you can safely use vessel sealer or not, whether there is safe distance between important structures or not, and then dissect if needed, suture if needed. So these are the things where you should be cautious about using an advanced bipolar. Maintain at least 5 to 6 millimeter distance from the edge of advanced bipolar and any important structures, because most of the companies claim that their lateral spread is either less than 1 millimeter or 1 to 2 millimeters. So it is fairly safe to say that if you keep 5 millimeter distance minimum, at least, from all the important structures between the edge of the bipolar and the important structure, you would be riding in the safe zone. Understanding the vessel sealing devices, their mechanisms, their characteristics, their surface, the tissues, tissue composition, and the interaction between the vessel sealing devices and tissues is crucial for effective and safe use. You cannot just say that I have this device from a very good company, less than 1 millimeter lateral spread, I can use it anyhow, anywhere. No, it depends on what tissue you are applying on, what kind of dissection you have done, what kind of case it is, whether you are dealing with a very complex case where all the important structures are stuck together. So it depends on so many things that what your safety margin is going to be. In future, more research into the surface characteristics of the contact surface with the minimization of thermal spread could lead to an improved seal strength and overall device performance. I think this is what most companies are working on. They're trying to optimize the vessel sealing mechanism, trying to make it faster, trying to reduce the highest temperature required for vessel sealing, and trying to reduce the thermal spread. Thank you so much for your kind attention. If there are any questions, we will take it in the discussion. Thank you.
Thank you, Dr. Suyash. It was a very interesting discussion from your end. You went into the details of the advanced bipolar systems. It is very important. I thought it will be covered in the previous discussion about the use of bipolar energy. See, bipolar forceps form an integral.
Hello, everyone. First of all, thank you, IAGE, for giving me the opportunity to present this topic of advanced bipolar and vessel sealers.
Sorry, there was an interruption. The presentation started again. So it is very important for us to understand that the bipolar forceps is a irrepressible part of every surgical trolley, especially when it comes to minimally invasive gynecology. And we have to understand that it is the surgeon who is using that energy in a judicious way to execute his surgery and to have the desired tissue effect. The advanced bipolars are just trying to make things simpler and reduce the the operator bias in this and make the sealing more streamlined, so it is reproducible and replicable by most of us. About the important thing which Dr. Suyash highlighted in the end of the discussion was the use of the E-cut, the new bipolar modified tip from Bissinger, which is using the bipolar energy in a way that it seals and it can be used as a cutting tool as well. So these modifications make the instrument have more functions, and you have to replace the instrument less often, so makes the surgery faster. It holds, it grasps, it dissects and seals, and finally eventually cuts the tissue, making the surgery faster and swifter. One has to understand that as these refinements come ahead, we will be able to use it more judiciously with lesser side effects. Until then, we have to use these devices with extreme caution. we will discuss in detail the nuances of this modified technology. So please stay back. Also, so we can have Dr. Suyash answer your queries on these modified bipolars as well.
Thank you, sir.
Any comments by you, Dr. Suyash? Finally.
No, I think what you pointed out was very right, that even the traditional bipolar can be used as a vessel sealer if you apply adequate pressure and if you know how to use your bipolar and energy. But that, I mean, surgeon has to master that skill. And what advanced bipolars are doing is that because of the computer algorithm, the life becomes easy. You don't have to think that much. All you need to do is focus on your dissection. Just create adequate safety margin. That's it.
Yes. So the golden tips were very useful, and it will help all the users to choose their vessel sealer or the advanced bipolar for better output. So as we have discussed so far, that electrosurgery, the bipolar, the monopolar, now we come to the next option, that is the ultrasonic energy. Ultrasonic energy changed the game in the last 10 or say more than 10, last 15 years. We have seen it being used in every event, and a lot of surgeons are embracing this new technology. It has its advantages, and to highlight these, we will have Dr. Sanket Pisat presenting his presentation or understanding of ultrasonic energy in minimally invasive gynecology. Dr. Sanket Pisat is an eminent endoscopic surgeon from Mumbai, and he is attached to several hospitals and is a great teacher. And now he will throw light on this concept or the principles of ultrasonic energy in minimally invasive surgery. Dr. Sanket.
Thank you, sir. Thank you very much. At the outset, let me thank Dr. Ameya Padmawar, Dr. Pandit Palaskar, and Dr. Kalyan Barmade and entire team IAGE for giving me this opportunity. And without any further delay, I'm going to share my screen so that we can have a look at the presentation. And of course, questions and comments are most welcome afterwards. Is the audio audible or not? I'm sorry. I need to share again. Please hold on. Do let me know if the audio is audible or not. For discussion today is ultrasonic energy in endoscopy. And this is a very important topic because the surgeon must understand the complete working of this very advanced energy source in endoscopic surgery in order to deliver the best result to his or her patient and to maximize patient safety. So we are going to be looking at the physics behind the working of the ultrasonic scalpel and also the optimum way in which the ultrasonic scalpel can be used so as to provide best results to your patient. Before we start off, it is a good idea to understand a little bit about the working of this instrument. As such, there are three spectrums of mechanical waves. Infrasonic waves, which have got frequencies below 20 cycles per second. Audible or sonic waves, which are confined to a frequency range of between 20 to 20,000 cycles per second. And then there are ultrasonic mechanical waves, which have got frequencies above the audible range, which is 20,000 cycles per second or more. The harmonic or the ultrasonic scalpel operates at about 55,000 cycles per second. So this is way beyond what the human ear can hear at all. The second thing to remember, and this is very important, is that electrical energy from the generator is converted to mechanical motion before it exerts an action. What does this mean? This means that there is no form of electricity passing through the patient at all, neither monopolar nor bipolar, and therefore it gets rid of a variety of problems that electrical instruments may have, which we will be seeing shortly in this discussion. The handpiece houses we will be seeing the pictures of the exact composition of the instruments, but I'm sure most of us have seen the ultrasonic scalpel being used sometimes. So the handpiece or the cable which is connected to the hand instrument houses the ultrasonic transducer. And this ultrasonic transducer is nothing but a series of piezoelectric ceramic discs. These piezoelectric crystals, when stimulated with electricity, produce an ultrasonic wave. Because of the expansion and contraction of the piezoelectric ceramic discs, there is a mechanical vibration which is created. This mechanical wave is then amplified as it passes down the blade. By blade, I mean the instrument which goes into the patient's body, and reaches a maximum amplitude of about 55,000 cycles per second at the tip of the blade. So let's see how that works. This once the blade is activated, these are the piezoelectric crystals over here. The electricity comes in from here. This stimulation causes movement of the piezoelectric crystals, and the harmonic wave is initiated, and this wave passes as a vibrational wave to the hand instrument and then to the patient. Notice again that there is no electricity flowing into the patient at all. So this was the transducer that I talked about. In most instruments, this will be found as a separate silver colored cable that is attached to the back of the instrument, and in some it may be integrated as well. So this is the transducer. This is the hand holding portion. This is the hand piece where the instrument is held, and the shaft of the instrument is also called as the waveguide. This is from where the ultrasonic wave comes in. Now coming to the tip of the instrument, this has got two parts. One is a straight portion which we call as the blade. This is the part that actually moves inside the patient's body. And this is the jaw which approximates against the blades and holds the tissue close inside the blade and the jaw. So these are the two parts of the instrument at the tip. The jaw is padded with a white coating so as to offer a good hold to the tissue. So you can see that when the tissue is held and activated, it not only cuts but also seals the edges of the tissue. We are going to look at that. Also, if played in very slow motion, you can see that the tip of the blade has longitudinal vibration, and in some brands there is a torsional vibration as well. One blade is fixed and the other blade has got a vibration, and this results in the cutting of the tissue. When the blade is coupled with the tissue, it causes intercellular friction. So this is the action on the tissue per se. When the blade is coupled with the tissue, it causes friction between cells, and this causes the breakdown of hydrogen bonds. These hydrogen bonds are broken and the protein within the cells is denatured. This forms a sticky coagulum, and this allows the device to seal the vessels. Like I said before, an ultrasonic instrument completely eliminates the risk of electrical injury to the patient as well as to the surgeon, because there is no current flowing through the machine at all. So several problems related to electricity like sparking or capacitance or injuries because of leakage of current from the shaft of the instrument, like we get in monopolar coupling, all of these injuries are completely eliminated. So this is the tissue cutting. It holds, it causes desiccation or breakdown of hydrogen bonds and thereby results in the cut. Now, how does it cause vessel sealing? So it not only cuts, but it also causes sealing of the vessels. So how exactly does it cause sealing of the vessels? Sealing of the vessels is caused by two things: the heat generated during the friction as well as the tissue compression. So coagulation with ultrasound requires compression of blood vessels. This compression is very important. What happens because of these compression as well as the friction which is generated? The hydrogen bonds are broken and the protein in the cells is denatured. This denatured protein then forms a sticky coagulum. Internal heat, tissue heat generated from friction is present. This seals the walls of the vessels. And the last point is simultaneous cutting and coagulation take place. Now it is important to remember that the importance of compression cannot be forgotten here, It is because of this compression that the heat is not allowed to extend beyond the jaws of the tissue. In the absence of compression, the blood in the tissue itself acts as a conduit for the heat to dissipate, and this causes tremendous amount of lateral spread. Hence, with this particular instrument, there is very minimal lateral spread, just to about 5 millimeters or so, unless the application of the instrument is for a long period of time, and the cutting and coagulation take place at a lower temperature than electrosurgery. This lower temperature is essentially because the tissue is compressed between the jaws, there is no dissipation of heat outside, and so lesser heat is required to achieve the same sealing effect than it would be required if a regular bipolar was used. Also, because of the compression, there is very minimal lateral spread, lateral thermal spread to the surrounding tissue, and we are going to see this in the subsequent videos when we look at them. So now comes the question of how to use. Before looking at how to use, let's see a little bit more about the concept of node and antinode. Nodes in physics represent point at which there is no displacement in harmonics, and antinode represents the point where there is maximum displacement. Cutting the technical part apart, the node of the instrument is located close to the jaw of the instrument, and the antinode of the instrument is located close to the tip. What this means is that the part of the blade, the black blade near the joint, is going to move the least, and the part of the black blade near the tip is going to move the most. And hence, utilizing the tip of the instrument for cutting is associated with increased cutting, and conversely, utilizing the more proximal portion of the blade will result in more hemostasis and slower cutting. So this is a phenomenon which is very important for the operating surgeon to understand. Once we have understood this, let us see again how to use. So when the machine is switched on, there are two settings which are seen. One is called as the minimum setting and one is called as the maximum setting. It can either be user managed or system managed. So let's talk about user managed first. In user managed setting, the power settings on the generator sets the current delivery. So 1 is for minimal displacement of blade and 5 is for maximum displacement of blade. That means if I have this controlled in a foot switch and a hand switch, and if I press the minimum pedal, there will be minimum displacement of blade, resulting in more coagulation and less cutting. And if I press on the maximum, there will be maximum displacement of blade, resulting in less coagulation and more cutting. You can see this, that this is the minimum and this is the maximum. But sometimes we also have situations where the unit is system managed, in the sense that we may start off with a minimum current setting, but as the system senses a change in the impedance, the generator itself adjusts the current to maintain the maximum blade displacement. So as the tissue starts denaturating, it gets harder, and then the blade senses that the impedance or the resistance of the tissue has increased, and it adjusts the speed of the blade accordingly to give you maximum and best cutting effect that you desire. So you can set it to the minimum or maximum, whichever way you want. System faults may occur when the impedance is too high because the blade is unable to vibrate, and hence it is advised not to hold too much of tissue in the blade of the harmonic before you are planning to deliver the current. So this is the difference between small blade displacement and increased blade displacement. The top image shows you what happens if you have put the system on minimum mode. So this is decreased blade displacement, and the bottom one shows you increased blade displacement, giving you faster cutting. Though this is not visible to the naked eye, you can see that I have started the ultrasonic scalpel, but the black blade is not seen to move. However, when this is dipped in water and the machine is activated, you can see that there is a sharp burst or a sharp jet of water which starts moving just because of the displacement, and in the maximum mode this displacement is even more, giving almost forming an aerosol of the liquid that is used. Incidentally, we use this for best cleaning of the instrument after the surgery. Now coming again how to use the instrument, there are several factors that determine how the instrument will work. So if you want maximum cutting, then it is advised to increase the power level. That means use maximum displacement of the blade. So use the machine on 5. Cut your tissue with the distal portion of the blade. Don't hold the tissue in the entire blade. And slightly upward traction or tension on the tissue applied with the tip of the blade after holding it causes faster cutting because the tissue is placed under stretch. If you do not want fast cutting but you want more hemostasis, conversely then it is advised to decrease the power level, use the proximal portion of the blade and keep the tissue relaxed under no tension so that there will be maximum coagulation and less of cutting speed. So these are essentially the factors that determine how the harmonic or how the ultrasonic will work. Time on tissue. Spend more time on tissue, there will be more coagulation. So here you can see as these factors decrease, you will get more hemostasis. As these factors increase, you will get faster cutting. So for example, the time on the tissue is one independent factor out of all of this. Blade pressure. As the blade pressure decreases, you will get more hemostasis. So you may not lock the blade, you may keep it just partially unlocked. As the tissue tension decreases, you will get more hemostasis. As the power level decreases, you will get more hemostasis. The blade sharpness is not under our control, and the blade location, proximal versus distal, which I already talked about. So these factors, the surgeon can literally play around with these factors to determine what is the final effect on the tissue that he or she wants to actually achieve. Now coming to the actual applications of the instrument. There are several applications and ways in which the instrument can be used. One of the applications is called cavitation. So what happens is the motion of the ultrasonic blade creates a small area of transient low pressure at the tip. When this low pressure area is created, the intracellular fluids will vaporize at lower temperatures. With vaporization, these fluid vapors expand and cause the adjacent tissue layers to separate. So it is almost as if the instrument is doing the dissection for you. So the tissue layers separate and you can cut one layer in preference to the other layer. So here you can see we are dissecting the UV fold. It has been held, and can you see this extension of the bubble which is going beyond the UV fold and giving me the easy plane of dissection. You can see the steam proceeding into the tissue and itself giving me the correct plane of dissection, thereby making surgery that much more safer. The other applications, one by one, if we see them, they are cutting of the tissue, which is very obvious, and we use it for cutting of the tissue on either the minimum or the maximum mode. One of the important things that has to be remembered while we are cutting the tissue is the concept of active blade and passive blade. Now here we know that this is the active blade and this is the passive blade, and it is a good idea to keep the active blade away from any vital structure. Now at this point of time, I know I am going to be cutting close to the uterine vein, so this active blade needs to be turned outwards and the passive blade needs to be turned inwards, so that the active blade will not make direct contact with the vital organ, and it is the active blade which gets extremely hot and can damage the tissue both by vibration as well as transmission of heat energy. So keep the active blade away from the vital structure. Now here I have negotiated beyond the area of the uterine artery, and now I am at the level of the uterosacrals. So now I am confident enough that I can turn the blade around, and if I want, I can thrust the active blade inside and perform the cutting motion without any problem. Ignorance in using the instrument in this manner can sometimes lead to complications. For example, in this case, I am doing the same thing on another patient, but not mindfully, I decided to use the active blade inside, and unknowingly, after using the active blade, you can see that it touched the uterine vein, and then of course the rest of the story is well known. It becomes very messy, one has to coagulate again and again, the bleeding doesn't stop, and you don't really want to use it in this way. So remember to keep the active blade away from any vital structure to avoid any problems. The next application of this instrument is back scoring. By back scoring, I mean that the instrument can be used without closing the jaws, simply by the active blade of the instrument. The motion of the back of the blade, even though it is not seen, it can just be used like a monopolar hook where you move it over the surface of the tissue, and by virtue of its vibration it cuts. This kind of application is used in gynae endoscopy, particularly for the sake of opening the vault in hysterectomy, like I am doing now. So we have put in a ceramic cup or a tube inside the vault, and we are opening the vault over it. So here you can see, without closing the blades, without holding the tissue in between the blades, I have got the action of a cutter with just one single blade. Same thing can be done for opening the capsule of a myoma as well. And once it is open, then you can thrust the smaller blade inside, or the moving blade inside, and then you can continue to perform the cut. So we are going to perform a circumferential cut over here using the blade. Once the tissue is open and you have access to the other side, it is easy to insert the harmonic inside and continue. Another application is drilling or otomy. We generally do not use this in gynecology. Surgeons use this for making a hole over the bowel, but sometimes in gynae this can also be used. Here I am going to perform a salpingo-oophorectomy. The ureter has already been visualized and pushed a little down by incising the peritoneal fold. Now I want to make a window in the broad ligament before I coagulate and cut the IP ligament. So here, after confirming that the ureter is down, I am using a single blade to make a hole in the peritoneum over the infundibulopelvic ligament and then stretch it, rather than having to hold the tissue inside. So here you can see ureter is comfortably down. I have made a hole, and now I will be able to coagulate the tissue and cut it. So this works for making small holes in the peritoneum rather than using a scissor. Then we come to the application which is sealing. So sealing, of course, is one of the important applications, and in sealing, as we will see shortly, there is also another application which is called advanced hemostasis. And in this sealing, what is happening is we are using the device on the minimum mode. On the minimum mode and with the tissue held entirely in the grasping jaws, you can see that the coagulum formation does happen between the tissue which is held between the two jaws. This is done at 2 or 3 or 4 places in order to achieve a good seal, and then the tissue in between is cut. Here incidentally I am using the advanced hemostasis function, which I am going to talk about, and this function ensures that even without the use of a bipolar, in some cases you can achieve very good hemostasis with minimal lateral spread. And using the advanced hemostasis function, it is possible now, according to the company recommendations, to use or seal up to 7 millimeter. So this is the advanced hemostasis function. There is a small green button available on the side of the handpiece, and when you press advanced hemostasis, it causes more correction, or it causes more coagulation of the tissues, and thereby gives you better hemostasis. Now, one important thing to understand is, though we are using advanced hemostasis, there is still no current flowing through the patient. So how does this advanced hemostasis really work if there is no current flowing through the patient for the purpose of causing coagulation? The concept explained by the company behind this phenomenon is adaptive tissue technology. And what exactly happens in adaptive tissue technology is that as the tissue is as the blade is held against the tissue and the blade is activated, there is an increase in temperature of the tissue with time. The frequency remains stable at 55,000 cycles per second. At a particular point, because of the increase in temperature of the tissue, the frequency of movement of the blade starts decreasing, and this may result in a problem, or this may result in insufficient hemostasis for the user from his or her point of view. So what the machine does, the machine is able to sense that this decrease in frequency has happened. Once the machine senses that this decrease in frequency has taken place, what the machine does is that the machine adapts, and because the machine adapts, it causes a change, or it causes a slight modulation of the frequency to keep the tissue effect still at the optimum level. So sometimes it may increase the power setting, and sometimes this power setting may even decrease down, so as to make sure that the tip of the blade and the tip of the instrument do not get very hot, and there is improved coagulation as compared to what you would achieve with a standard ultrasonic scalpel if you used it on the minimum mode. So what are the other applications? One of the applications is dissection. You can simply use it as a dissector, I mean like a cold instrument, where you use it without energy to simply dissect the tissue away from, to dissect the planes of the tissue away from each other, and then you can combine it with the cutting function, much the same way as you would have probably used a blunt grasper or a Maryland in order to do the surgery. So it can be used very well for dissection because one of the jaws moves and it opens out very widely. This is very good for us for doing dissection and pushing the tissue planes away. So other than dissection, there is also the concept of lateral spread. Now here, this is not an ultrasonic, this is a bipolar, and you can note two things. See the amount of lateral spread that is happening here. This is up to a centimeter or sometimes 2 centimeters depending upon the time of application and the nature of the tissue. But needless to say, there is a lot of lateral spread of current, and the surgeon must be aware of the lateral spread that is happening if this sort of instrument is being used. So it is giving very good coagulation, but there is lateral spread. Here, compare when the ultrasonic is used, the smoke generation you will find is significantly lesser. Even also along with the smoke generation, you find that after the cutting has happened, you can see that these are fine edges of tissue. There is very minimal lateral spread on both of these edges even after the coagulation and the cutting has been done. So this is yet another very important advantage, that there is confined lateral spread. And note the sealing of the edges as compared to the bipolar where they were not sealed, they were raw. Precise cutting, by using the tip of the blade, we are able to make sure that we are cutting only what is intended. See that we are using only the fine 1 or 2 or 3 millimeters of the terminal blade, and you can see that you are able to cut exactly what you are holding between the jaws with hardly any lateral thermal spread and exact cutting of the tissue. So it makes for a very good cutter and a dissector. The third thing that surgeons really like it for is the concept that there is no current leakage. Imagine such a scenario where you are dissecting in the retroperitoneum. That was the ureter, this is the internal iliac artery, and we are going to perform a uterine artery ligation. So this is the uterine artery coming up over here. In performing this dissection in the retroperitoneum, sometimes you have to be working deep inside in the retroperitoneum, and assistance by your assistant surgeon may become very limited. So in that case, we need to be careful how we are going to use this instrument. Now, if we were using a regular bipolar here or any other modification of a bipolar device, there would still be electricity passing through the patient. At this point of time, you can see that all vital structures are close by. The ureter is running from here, and I am holding the uterine artery with my left grasper. And now I am going to coagulate this uterine artery, or better still, I am going to clamp or block this uterine artery using an energy source. At this stage, if I was using a bipolar, I would have to be doubly sure of no tissue touching anywhere along the instrument in this path, because you can see that though I have safeguarded the ureter with my left hand, part of this instrument may still touch the ureter, and if there is any current leakage, then it may happen that the ureter may get damaged. Here I am perfectly sure that other than the ultrasonic vibrational movement, there is nothing else which is happening. So the entire part of the shaft or the waveguide is safe. Even if it is touching the bowel in some part entirely, there is going to be no question of any current leakage, and there is not going to be any harm to the patient. So that is a significant advancement. Moving on to some variations of the ultrasonic. Now wireless instruments are available. These make things very convenient because there are no wires. It improves the dexterity of the surgeon. It improves the ability of the surgeon to move the instrument around greatly. And according to certain authors, these also have better vessel sealing and better cutting functions. However, the mechanism of action remains the same. Thunderbeat is yet another advancement in this area, where they have combined the capabilities of a bipolar along with an ultrasonic in the same instrument. So you have got a seal and a seal and cut, both available. By pressing the seal, it delivers bipolar current, and this bipolar current goes in and coagulates the tissue. Needless to say that by the ability of bipolar energy to coagulate large vessels is definitely better, and most endoscopic surgeons will vouch that it is their go-to instrument in case there is a heavy bleeding in the pelvis. One always switches over to the conventional and standard bipolar to achieve coagulation. So this Thunderbeat delivers bipolar coagulation as well as it delivers ultrasonic energy. And what it promises to the surgeon is this concept of intelligent tissue monitoring, where they say that it responds to changing tissue conditions by regulating energy delivery, so it does not allow the temperature of the tip of the probe to exceed beyond a particular point. And whereas conventional ultrasonic devices may have the risk of overactivation, as soon as the tissue is transected, it will measure that the tissue has got transected, and automatically the cooling phase of the instrument will start. So this is called as intelligent tissue monitoring. Also, another variation in this which is now available is called as the sonic beat. The company advises this as precise and efficient decision, and it is supposed to deliver faster and more precise dissection than the harmonic ace and the sonicision, though I have no personal experience of using this, enabling fine dissection, easier blunt dissection, and also what is promised is more secure grasping with a tip grasping force of up to 17 times more than other ultrasonic devices due to a wider jaw design. So I think that concludes the presentation on ultrasonic devices. Thank you very much for your patience and for listening. Hello everyone. Our topic.
Hello. Thank you, Dr. Sanket. It was an interesting insight again into the ultrasonic energy, and you covered all the points which pertain to it. The only disadvantage, as one can say, is that it is not a reusable instrument. I think the sonic beat and the thunder beat are supposed to be reusable, but the ultrasonic by J&J is a single-use instrument, and that makes the costing of the surgery little formidable unless it's covered in the insurance part. Another observation which we have had in clinical practice is instrument exchanges are very minimal, and it does holding the tissue, pulling onto the tissue, applying traction, cutting, sealing, all in one go. Also in retroperitoneal dissections, when it is used, an observation which we have noted is that it reduces the lymphoria or the microcapillary ooze. So it seals the smaller lymphatics and the capillaries as well simultaneously with that little heat which it generates. So all in all, it's a useful instrument, and of course, there are alternatives to it, and we shall have it in the discussions as we go on to the next topic. Thank you, Dr. Sangeet.
Thank you, sir.
Yeah. So the viewers can put their questions in the chat box so that the experts can answer them after all the presentations are over. The next speaker we call upon is Dr. Pranay Shah. Dr. Pranay Shah is an eminent endoscopic surgeon. He practices at Bhatia Hospital, Bridge Candy, and he's a great teacher. He's a faculty at IMAS, and he's going to highlight one energy source which we do not see very often used, but it has its place in the armamentarium of advanced gynecological surgery. He's going to talk about the physics and the applications of lasers in gynecological surgery. Dr. Pranay Shah, sir, you may start. Sir, please unmute yourself. Hello, sir, please unmute.
Clearly unmuted, so I think you have to do it from your side.
Okay. Please unmute, sir.
Yeah.
Now you're on, sir. Please start. Please unmute Dr. Pranay Shah, sir.
if you got his talk recorded, you can start, Dr. Amaya, sir.
Okay, yeah.
Hear me now? I think it's done.
Okay, yeah.
Can you hear me?
Yeah, we can hear you.
Yes, sir.
Please
Yes.
go on.
Can I share my screen now?
Yes, sir.
Please.
Are you able to see the presentation?
Yes, sir. Make it into PPT mode.
Yes. Are you able to see this?
Yes, sir.
So at the outset, I would like to thank the organizing committee of the IAGE, especially Dr. Pandit Palaskar, President IAGE, Dr. Kalyan Barmade, Secretary, and Dr. Amaya Padmawar for inviting me to speak in this symposium on energy sources in minimal invasive surgery. The use of laser in gynecological minimal invasive surgery was at its peak in the 90s and 2000s. During the early part of my training in endoscopic surgery, I was fortunate to watch masters like Kamran Nezat from USA using the carbon dioxide laser and Chris Sutton from Surrey, United Kingdom using the KTP IAGE laser. Improvements in other energy sources, mainly the monopolar, bipolar ultrasound, which we've already heard the previous experts, and the high cost of laser led to a gradual decrease in its use. A renewed interest in laser is seen due to technological advances like the new fiber carbon dioxide laser and the dual frequency diode laser. Laser is an acronym for light amplification by simulated emission of radiation. Over 40 different types of lasers have been developed for a wide range of industrial and medical applications. Lasers can be gas or solid. Commonly used gas lasers are the carbon dioxide and the argon gas laser. Solid state lasers include the Nd:YAG, the KTP, holmium, and the diode laser. The concept of stimulated emission was first proposed by physicist Albert Einstein in 1905. Light can liberate electrons from certain metal surfaces. The laser beam is an electromagnetic radiation similar to natural light, but it is created by simulated emission. As opposed to a natural light, laser is monochromatic, it is coherent, which means it is a single wavelength and is spatially and temporally in phase. The carbon dioxide, the previous slide. The carbon dioxide laser is transmitted through air. The beam is directed to the operative site through a series of hollow articulated arms and mirrors to bend the beam. The beam can be focused on a spot by using lenses, which are moved by using a joystick. The argon, Nd:YAG, KTP, and diode lasers are transmitted through a quartz fiber. Newer developments like the waveguide and the flexible fibers allow carbon dioxide gas laser to be passed through a fiber, making it more convenient to use. Three parameters determine the amount of energy delivered to the tissue: the wattage or power, usually 10 to 30 watts, the time of laser application to the tissue, and the spot size. To reduce the thermal injury, the laser beam or the fiber can be moved back and forth rapidly or used in an ultra or a super pulse mode. The power density or concentration of power in a small area depends on the power setting in watts and inversely to the size of the spot. For example, at 10 watts power, the power density is 4,000 watts per square centimeter if the spot size is 0.5 millimeters, and 1,000 watts per square centimeter if the spot size is increased to 1 millimeter. On application of the laser, a spot or a crater is created. Smaller the spot size, deeper is the crater. In the crater, there are 3 zones of tissue injury. In the center of the crater represents the vaporized tissue or the V-shaped defect. Surrounding the vaporized area is an area of necrosis or irreversible tissue damage. In this zone, smaller vessels less than 1 millimeter size are sealed. The deepest area is that of a reversible thermal damage. By controlling the power density, effects of cutting, vaporizing, and ablation can be controlled. Using a pulse laser allows the high power densities, allowing a pure cut to ablate a tissue without any coagulative necrosis. This slide shows the comparison of different lasers. The carbon dioxide laser is the most favored laser in laparoscopy due to its minimal depth of penetration, 0.1 to 0.5 millimeters, and minimal lateral spread, which is 0.5 millimeters. Nd:YAG laser, with its ability to work underwater and a deeper penetration of 3 to 4 millimeters, makes it an ideal for hysteroscopic surgery. Dual wavelength diode laser has the ability to cut and coagulate simultaneously, making them useful in laparoscopic and hysteroscopic surgeries. Optical penetration of various laser wavelengths depends on their absorption in the tissue, namely water, hemoglobin, and fat. Carbon dioxide laser, with its least penetration, makes it use safe near vital structures like the ureter, bladder, and the rectum. KTP laser is selectively absorbed by hemoglobin. Combine this with its low penetration, it makes it a useful laser in presence of hemosiderin and blood, especially in cases of endometriosis. The Nd:YAG laser is not absorbed in water. Together with its deep penetration, it is a useful laser for hysteroscopic endometrial ablation. In clinical practice, in 1973, Bellina used the carbon dioxide laser for treatment of cervical erosions. In 1974, he used the carbon dioxide laser for treating cervical intraepithelial neoplasia. By coupling the carbon dioxide laser with operating microscope at laparotomy, he used it for microsurgery of the fallopian tubes. Key and Dixon in 1983 used the argon laser through a quartz fiber to treat endometriosis laparoscopically. In 1985, Lumeno and 1986, Daniel used the Nd:YAG and the KTP lasers to treat mild, moderate, and severe endometriosis. Carbon dioxide laser is the most commonly used laser in laparoscopic surgery due to its safety. It is a gas laser with a wavelength of 10,600 nanomicrons in the invisible infrared range. The laser is made visible using a helium neon beam, which is red in color, which is used in sync with the gas laser. Carbon dioxide laser is an excellent cutting and vaporizing tool with many applications in laparoscopic surgery. Its main use is in endometriosis surgery for adhesiolysis, vaporizing lesions, excising implants and nodules, and vaporizing the endometriotic cyst lining. Although it has been used in many other applications as shown in this slide, its use has not been proved to be superior to conventional electrosurgery in these indications. A video showing the use of carbon dioxide laser beam to vaporize peritoneal endometrial deposits. Note that the carbon dioxide laser is invisible and the helium neon red beam is used along with the gas beam to make it visible. As carbon dioxide laser is not effective in hemoglobin or chocolate fluid, irrigation with saline is needed to keep the field clean and the laser effective. With carbon dioxide laser, there is very minimal thermal damage to the adjacent tissues or scarring. The next video shows the use of carbon dioxide laser beam to perform adhesiolysis. A metal rod is used as a backstop to avoid injury to the adjacent bowel. So this can make the laser use safe. In this video, carbon dioxide laser fiber or a Omni guide is used to treat endometriosis. A series of dots or craters are created, joining to make an incision. Small vessels are sealed, thus giving a clean, bloodless field. Once the lesion is completely incised, the lesion can then be dissected free from the underlying tissues using the dissection technique. If the endometriotic implant is near a vital organ, saline is injected subperitoneally. As carbon dioxide laser is absorbed by water, making it ineffective, the underlying structures are protected. The endometriotic implant can then be excised without the risk of damage to the ureter, bladder, or rectum, which lie underneath the implant, making this a very safe alternative as compared to the other energy sources. The carbon dioxide laser can be coupled to a robotic arm and can be used during the robotic endometriosis surgery. In this case, it is shown to be used for adhesiolysis, separating the bowel from the lateral pelvic wall. It can also be used to excise peritoneal implants using the robotic arm while doing robotic surgery. Bailey et al. Compared monopolar with carbon dioxide laser and showed that increase in monopolar power settings increases the lateral thermal spread in a linear fashion. However, with carbon dioxide, increasing the power increases only the depth of incision and the cutting ability without any increasing in the lateral thermal spread. Croma et al. In a study of 90 women compared ovarian stripping with carbon dioxide laser vaporization of the cyst wall. Patients treated using carbon dioxide laser had a recurrence as early as 7.5 months compared to 18 months in the stripping group. Also, the laser group had a significantly higher recurrence at 1 year of 30% as compared to the 11% in the stripping group. I'm not able to go to the next slide. Yeah, okay, fine. Although the cystectomy is superior to carbon dioxide laser application in delaying or preventing recurrences, there is a growing concern over the damage to the ovary in patients desiring fertility. Setio et al. Observed that in absence of a clear cleavage plane during endometriosis stripping, involuntary removal of healthy ovarian tissue is inevitable. Lee and Suk-Som expressed concern of ischemic vascular damage to the residual ovary due to bipolar coagulation and sutures from hemostasis after stripping. Seridogon observed that endometriotic cells are located only on the surface of the cyst up to 0.5 millimeters. Carbon dioxide laser is an ideal choice of endometrioma cyst vaporization due to its shallow depth of penetration of 0.5 millimeters. A 1.5 millimeter layer of fibrosis is the natural protection to the underlying ovarian parenchyma from thermal damage during the laser application. Solakadis and Pedos compared ovarian stripping with a 3-step technique for treatment of ovarian endometriomas. The 3-step technique included laparoscopic cyst drainage and lavage with a biopsy of the cyst, lining in step 1, 3 months of GnRH agonist injections in step 2, followed by a second laparoscopy and a carbon dioxide laser vaporization of the cyst lining in step 3. They found a significantly higher antral follicular counts at 6 months in the group treated with the 3-step technique. Since bleeding during the stripping technique is mainly from the hilar vessels, Donez and Napi used the carbon dioxide and diode laser together with stripping zinc and found higher pregnancy rates with less than 2% chance of a recurrence. Munoz et al. Compared stripping with carbon dioxide laser vaporization and noted an higher levels of anti-Mullerian hormones and a higher antral follicle count in the laser group at 6 months. A video showing the use of carbon dioxide laser to treat ovarian endometriomas. The cyst is drained, lavage can notice the precise coagulation and the minimal depth of penetration while carbon dioxide laser is being used. Next video shows the use of carbon dioxide laser to treat an ovarian endometrioma. The cyst is drained, lavage given with saline and biopsy taken and everted. The cyst lining is vaporized using the laser. Notice the paintbrush technique which is being used to completely vaporize the cyst lining with a very minimal depth of penetration. The KTP IAGE laser and the argon laser have similar wavelengths in the visible spectrum with the green or a blue-green color. The spot size is decided by the thickness of the fiber used. Both have selective absorption by hemoglobin, hence useful in the treatment of endometriosis in the presence of chocolate, fluid, and blood. They also produce less plume than carbon dioxide. Since the laser can damage the retina, wearing protective glasses is a must. However, the glasses distort the image and visualizing small lesions is difficult. He treated all stages of endometriosis using the argon laser with good results. The NDAC laser is an invisible beam with a wavelength of 1064 nanomicrons. It is guided through the laser fiber using the neon helium spot similar to the carbon dioxide laser. It is readily absorbed in the tissues with a penetration depth of 3 to 4 millimeters. Since it is poorly absorbed in water, it is excellent for laser for hysteroscopic surgeries. Newer laser fibers with sapphire tips and sculptured laser quad fibers allow its use in laparoscopy and hysteroscopy simultaneously. The diode or a semiconductor laser is one of the cheapest and simplest form of solid-state lasers. Dual emitter diodes with two frequencies at 980 and 1470 mu microns combine excellent cutting and coagulation properties. The laser emits various colors, blue, green, and red, depending upon the size of the fiber used. Stefano Angiani treated 50 patients with chronic pelvic pain and infertility due to endometriosis, laparoscopically using a diode laser of 1000 mu microns to vaporize implants and excise nodules in deep infiltrative endometriosis. A video of one of my cases of bad obstetric history with a biconjugate uterus, where I used the diode laser to incise the myometrium in a case of biconjugate uterus. The laser fiber emitting a blue color is seen. Notice the clean incision and the absence of any bleeding while the myometrium is being incised, and also very minimal coagulation of the edges, thus preserving the myometrium in this delicate surgery. Once the partition between the two horns has been completely excised, the two horns were unified using interrupted sutures. This is an older video, so we have used saying vicryl number 1 to unite the horns. Currently, I would prefer the use of barb sutures if available. Laser has a potential to cause serious injuries. Gynecologists who want to use laser should receive special training, which should include didactic instructions and practical hands-on stimulation in dry lab and animal models. Protective eyewear appropriate to the laser should be worn by all OT personnel. As live viral DNA and papilloma virus have been detected in the laser plume, adequate scavenging systems should be available while lasers are being used. To conclude, laparoscopic laser vaporization is a good option for treatment of endometriomas, for patients who wish to preserve fertility. Carbon dioxide laser laparoscopy can be useful in the treatment of deep infiltrative endometriosis. However, currently their use is limited by the high costs, low availability of the equipment, and inadequate training facilities. Thank you for the patient hearing. Any questions I can take at the end?
Thank you, sir, for introducing to us this modality or energy source, which has applications for its precise, application of energy and its role in preserving ovarian reserve. So it has been used, and most of the studies are around its preservation of fertility in endometriosis. So maybe there will be a good surge of its application in the near future. And of course, you showed that it is used along with the robo as well. So thank you. We'll take the questions. There are some questions already on this after the next presentation, sir. Thank you very much. So we come to our next speaker. Gynecological surgery is not complete without us discussing about hysteroscopic surgery. So when we come to hysteroscopic surgery, there are different modalities of energy which is used for performing advanced hysteroscopy. And Dr. Anuja Kulkarni from Latur, from Mamta Hospital, Latur, is going to throw some light on the use of energy sources for operative hysteroscopy. Dr. Anuja, please start with your presentation.
I thank Dr. Ameya Padmawar, Dr. Pandit Palaskar, and Dr. Kalyan for giving me this opportunity to talk on energy sources for operative hysteroscopy. Till now, we have seen all eminent speakers talk about the various energy sources being used for laparoscopy. Dr. Ameya, can you hear me?
Oh, very well. Please
continue. Thank you. Thank you. So greetings from Mamta Hospital, Latur. So as we all know, hysteroscopy initially was used only for diagnostic purposes for a long time. And with the advent of newer technology and energy sources, we are now being able to use hysteroscopic surgery to deal many gynecological conditions in cases of infertility, as well as to avoid hysterectomy. The energy sources which are commonly being used in hysteroscopy are the electrical energy and the laser energy. So as you have already seen, whenever you decide which energy source to use, you need to know the basic physics, which have been very nicely explained by all the previous speakers. You need to know its applications, its limitations, and also the potential hazards and complications that can occur because of the use of these energy sources. Electrical energy, that is the electrosurgery, with its monopolar and the bipolar applications, is by far the most widely available, most economic and versatile energy source in our armamentarium. So as already told by, I won't go into the details of the basic physics of electrosurgery. Dr. Shinjini has already covered it very well. So the monopolar electrosurgery is where the current goes from the electrosurgical unit through the active electrode to the tissues where we want to bring about the effects. Then from the tissues, it travels through the patient to the return or the return electrode, and then back to the electrosurgical unit. So the various waveforms as shown are the continuous waveform, whereas which brings about the cutting effect of the tissues. Especially if it also depends on the electrode configuration, and the intermittent waveform is there. So the tissue effects brought about by monopolar electrosurgery is basically, it depends under the various variables which are under the surgeon's control, like the power settings, the electrical waveform, whether you're using the continuous current or the intermittent current, that is whether you're pressing on the yellow pedal or the blue pedal, and also on the electrode configuration. That is, if it is a thin wire which is gives a more concentrated current, or whether it is a broader barrel. So this will decide the tissue effects. So during hysteroscopy, monopolar electrosurgery is commonly used through the hysteroscopic resectoscope. So this is an assembly which has the inner sheath which and the outer sheath for the inflow and outflow of the irrigation fluid, the working element through which the electrode can be passed. Here we can see a hysteroscopic surgery where we are using the loop electrode. The underwater cutting current of usually 100 to 120 watts is used for cutting of the tissues and resection of the tissues in hysteroscopic myomectomy. Endometrial ablation can be brought about with the help of a broader electrode, which is the roller ball. We can use a continuous or a coagulating or a intermittent current. As already shown, intermittent current is more commonly used for fulguration. Monopolar electrosurgery has shown to cause many complications. Complications like skin burns at the alternate sites because of alternate sites of passage of the current at the site of the return electrodes can be seen if the return electrode is not properly applied to the patient. In hysteroscopic surgery, the depth of tissue injury with monopolar electrosurgery is more as compared to any other energy source, because of the high temperatures, which is as high as 400 degrees Celsius, and hence there is a risk of perforation and also electric burns to vital organs like the bowel and the bladder. Also, the lateral thermal spread to the surrounding endometrium is also more, and hence causing scarring of the endometrium. The most dreaded complication because of monopolar electrosurgery in hysteroscopic surgery is fluid overload, because with monopolar for electrosurgery, we have to use the 1.5% glycine as the distending medium, which is a hypotonic solution, and absorption of this glycine in large amounts can cause fluid overload, hyponatremia, as well as neurotoxicity like encephalopathy and blindness. And that is why bipolar electrosurgery is becoming more and more popular in hysteroscopic surgery. Here, the current passes from the electrosurgical unit from the afferent electrode through the tissues to the efferent electrode, and then back to the electrosurgical unit without passing through the body of the patient. Initially, the Versa-point bipolar system had become very popular along with bipolar electrodes, but it was a disposable and a semi-rigid hysteroscope with a disposable outer sheath, and it is not being used commonly nowadays. The bipolar electrodes with these various tips, that is the spring, the twizzle, and the ball, can be used through this 5.5 millimeter operative sheath through this 5 French working channel. So what is the physics here is in during hysteroscopic surgery is this electrode has an active electrode at the tip of the electrode, and the return electrode is on the shaft, and this is separated by the ceramic sheath. What happens is the bipolar generator brings about an initial high peak of high voltage current, which brings about this electrical arc. This electrical arc causes dissemination of the sodium chloride into plasma, that is highly energized sodium particles, which bring about the various tissue effects during bipolar electrosurgery. Here we can see a uterine septum being cut with the help of a bipolar twizzle electrode. The depth of tissue injury with the use of bipolar electrode is much less as compared to monopolar electrosurgery, and the distending medium which is used is normal saline, and that is why the risk of perforation as well as fluid overload, or rather hyponatremia, is very less with the use of bipolar electrosurgery. So these are the advantages: low temperatures as less as 50 to 70 degrees Celsius, hence leading to less depth of tissue injury, less collateral damage. It also does not, bipolar electrosurgery does not interfere with other electronic gadgets that are applied to the patient, like the ECG electrode or the pacemakers, and there is no risk of hyponatremia and neurotoxicity. The bipolar resectoscope is now being very popularly used. Initially, the 26 French with an outer diameter of 8.6 millimeter was being used, and now gradually the diameter is being reduced to the commonly and most popular being the 15 French, that is the 5 millimeter resectoscope, which can be used for office hysteroscopic surgeries. So this is a 15 French, that is a 5 millimeter hysteroscope being used, a vaginoscope entry without holding the cervix or even bringing about any cervical dilatation. You can see the myoma being resected. Normal saline, as I already mentioned, is being used as the distending medium. You can see the chips, small chips being removed with the use of this 15 French hysteroscope, and the chips can be removed, resectoscope, and the chips can be removed through the cervix without any cervical dilatation. Now we will go ahead to the use of lasers in hysteroscopic surgery. We have already seen Dr. Shah sir showing us the use of lasers in laparoscopic surgery. So as mentioned, the concept of lasers was initially put forth by Albert Einstein way back in 1917, and it was just an invention without any application, only used in science fiction movies for many years. Then in 1960, Maiman constructed the first working laser, and Goldrath used it for hysteroscopic surgery first in 1981. He used the Nd:YAG laser for endometrial ablation. So what is a laser? It is basically a monochromatic coherent collimated beam of light, which when it comes in contact with the tissue, it brings about these various effects, that is the photochemical, photothermal, but the effect that we use in surgery is the photothermal effect, where the tissues are heated up and the cells are coagulated or vaporized. Fiber optic lasers, which can be transmitted through quartz fibers and which can be used in liquid medium, are commonly used in hysteroscopic surgeries. So Nd:YAG was the first laser which was used initially, and followed by commonly now the most popular laser which is being used is the diode laser. We have published our work with the use of holmium-YAG laser for hysteroscopic septal transection in 2021. So as already mentioned by Dr. Shah, the tissue effects that are brought about by the various lasers depend on the various characteristics like the wavelength, the depth of penetration, and the absorption of the various lasers. So these are the various tissues, these are the various surgeries which can be done with the use of lasers during hysteroscopy. That is the septal transection, lateral metroplasty, intrauterine adhesiolysis, polypectomy, and enucleation or vaporization of submucous fibroids, and endometrial ablation, ablation of hypertrophied and anterior cervical crypts, and also Nabatean follicles. This video shows the use of the diode laser, which is a continuous wave laser for cutting the septum. The septum is being incised from the apex towards the base. The depth of tissue injury of the diode lasers is 0.5 to 1 millimeter. Diode being a continuous wave laser, it brings about a little bit of charring at the tissue interface. Diode is commonly being used by many surgeons in Spain and in Italy. We are using the holmium-YAG laser, which is a solid state pulse laser with a wavelength of 2100 nanometers, with a depth of tissue penetration of just 0.4 millimeters. It brings about various tissue effects like the cutting, coagulation, vaporization, and ablation. And that is why it is known as the Swiss Army knife of lasers. The holmium-YAG laser is commonly being used in urology, orthopedic surgery, and dentistry. We have been using holmium-YAG laser for hysteroscopic surgery at Mamta Hospital, Latur since 2004. The depth of tissue injury is least as compared to the other energy sources, which is just 0.4 millimeter. The tissue effects that are brought about is the cutting when the quartz fiber comes in contact with the tissues. Whenever we defocus the beam, we can bring about coagulation, and there is no tissue effect if there is more than 5 millimeters away from the tissue surface. We use a 2.5 millimeter operative hysteroscope with an outer diameter of 5.5 millimeter and a 5 French working channel, through which we pass this 400 micron reusable quartz fiber, which is used for the transmission of the holmium-YAG laser. The first surgery which we did with the use of holmium-YAG was in 2004, was the uterine septum. Incision of uterine septum was done by Dr. Vishwas Kulkarni, who is the urosurgeon in our hospital. He used it for incising the septum from the apex of the septum towards the base, we take horizontal incisions. So it is necessary to bring the tip of the fiber in contact with the tissues so as to bring out this precise cutting effect. There is smooth cutting. We use the normal saline as the distending medium for this laser. Here, this is the case of a post-abortal grade 3, stage 3 and intrauterine adhesions. The adhesions at the center of the uterine cavity are incised by the tip of the fiber, followed by those along the lateral uterine walls. You can see this surgery would have been very difficult with the use of cold scissors. We can see both tubal ostia can be visualized well. Fundal adhesions are being cut with the tip of the fiber, followed by the dense adhesions along the lateral uterine walls, which can be cut by angulating the assembly to the long axis of the uterus. The fibrous bands can also be vaporized. Lateral metroplasty can be done along to increase the volume of the uterine cavity. Here, the adhesions at the cornu are also being cut and dense fibrous tissue is being vaporized. The lateral thermal spread is very minimal, and that is why the endometrial regeneration is also very fast. We put in an intrauterine Foley catheter and give estrogens, high doses of estrogens to bring about the endometrial regeneration. This is the relook hysteroscopy being done 2 months after the prior surgery, which shows a well-formed uterine cavity without any recurrence of intrauterine adhesions. And even the tubal ostia can be visualized very well. The T-shaped uterus or the dysmorphic uterus has been shown to cause infertility as well as adverse reproductive effects. And lateral metroplasty has shown to improve the reproductive outcomes in these patients. Holmium-Meag laser can be very efficiently used for lateral metroplasty to increase the volume of the endometrial cavity and hence improve the implantation rate. The lateral wall on the left side is being incised by the, you can see the fibers are being cut layer by layer. We haven't had any complications till now like perforation or fluid overload with the use of lasers during hysteroscopic surgery. So, this was a case of postmenopausal bleeding with endometrial polyps with a stenosed cervical os. Vaginoscopic incision of the external os is being done with Holmium-Meag laser. You can see the multiple endometrial polyps. The base of the endometrial polyp can be cut with the use of these lasers. The advantage of this pulsed laser is the depth of tissue penetration is less, and also you can note that there is no charring of the tissues at the interface. We see a clean cut during the surgery. So bleeders can be coagulated by defocusing the beam, bringing the tip of the fiber a little behind and then defocusing the beam on the blood vessel. All the polyps are being incised at the base. The pedicles are being cut. If they are large polyps, you may incise the polyp through the center of the, in the center, so that it can be removed piecemeal. The assembly is very easy to use, tackle various pathologies even at the cornu of the uterus, since the fiber can reach the cornu very well. So here you can see this polyp at the left tubal ostium, which is being removed with the fiber. This is the end result after the surgery. So these are the hysteroscopic surgeries that we have done with the use of whole mag laser from January 2021 to July 2023. So what are the advantages of laser surgery? It is precise and quick surgery. So the faster you finish off the surgery, there is lesser the chances of fluid overload. There is minimum depth of tissue destruction and lateral thermal damage as compared to electrosurgery. You do not need cervical dilatation and hence can be used for office hysteroscopy. There is very little risk of fluid overload and no risk of hyponatremia. The maneuverability of the assembly is very easy, and though lasers are distributed because of its cost, we are sharing this machine with the urology department and we are using a reusable fiber, and that is why we have it proves to be very cost effective for us. For me especially, we haven't purchased scissors for a long time. Yes, we do need to know the precautions that need to be taken. We need to know the laser physics. We have to always remember to put the generator on the standby mode before we remove the fiber. And if you take that precaution, then there is no need to worry about firing the beam on the inflammables or then using any protective eye glasses. So now we have seen so many energy sources being used during surgery. Initially, the gynecologists were known to fear technology, especially the ladies. We didn't even use electrosurgery for any hysterectomy. But now that is not the case. We are using more and more technology. We are becoming techno-savvy. And we are not worried about the costs. And as already mentioned by all the previous speakers, every surgeon is comfortable and well-versed with a particular energy source which acts as a magic wand. But ultimately, a good surgery, the magic depends on, it is in the hands of the surgeon, that is the magician. Thank you very much. I thank you once again to give me this opportunity to present my work with this magic wand that I'm using for hysteroscopic surgeries.
Thank you, madam. Thank you, Dr. Anuja. It was very interesting to see your applications of laser, and definitely it has a role in fertility preservation, as you showed after the resection of the adhesions. So that was actually my question as to how does the body respond to the application of laser. So that proved that it is a safer modality and used judiciously can have better outcomes.
Yes, sir. This patient, which I showed, this patient conceived 3 months after the surgery, after the rear look surgery, and naturally.
Yeah.
without
Very
any
interesting.
treatment.
Thank you. So that brings us to the end of these presentations, and now we can have the questions.
Thank you.
So I implore all the viewers to put their questions in the chat box to be answered by these experts. To begin the discussion, I would like to put forth this question. See, we are seeing the upsurge of the use of a bipolar shearer in a lot of surgical videos put on the YouTube, and a lot of surgeons showcasing this technology in their surgeries. So there was a question which one of the viewers wants to know the mechanism of action and the lateral spread limits of this modification of bipolar energy. So if any of the speakers, Dr. Shinjini, Dr. Suyash, they can answer this question, or anybody for that matter on this panel.
You want to go for that, Dr. Shinjini?
Yeah. So basically the sharer, as I know, I've used the sharer, but it's not what I use for routine cases. For all my cases, probably I use the standard bipolar and the harmonic as a combined modality. But the sharer we have, and I've used it many times. From what I understand, the basic principle is bipolar energy, but it is a modified bipolar. So bipolar basically is a pure cut waveform. So pure cut meaning in general a low voltage waveform. However, the cutting action that happens when you press the these sharers, so in sharer you have the blue as well as the yellow, right? So when we are using the sharer, when you press the yellow, for that brief instantaneous instant, the voltage shoots up very high in order to give a cutting effect. That is what the sharer person, the Alan sharer person with whom I discussed, described me as to the effect as. Lateral spread, I really don't know. I'm not aware of how much is the lateral spread. Anyone can add.
Can I talk?
Yes.
Yes.
Can I make a comment?
Yes, sir. Yes, sir. Please do.
So I've gone through the whole gamut of transition from your simple bipolar without any alarm systems to the harmonic, to the ligature, to the Encil, and now the bipolar shearer. I think if you understand monopolar energy, we understand that monopolar cuts not only because of the cutting current, but also because of the reduce in the surface area. So that is how your spatula is designed, that when this surface area is large, it coagulates. When the surface area is reduced, it cuts, right? And your PCOD needle will always cut, it will never coagulate, irrespective of what waveform you use. So the same principle is now is used in bipolar, that although we always use bipolar as a coagulating current, because the surface area of the bipolar is reduced, because traction is given with the instrument, with the small tip of the instrument pulling the tissue towards you, the current from a coagulating current becomes a cutting current. So we are basically using the fundamental principles of monopolar energy, which were now put on to bipolar, and the bipolar coagulating device has become a cutting device. With some modifications in the circuit, as Sinjini mentioned, that the peak volume, voltage volume is raised, but there are actually different types of cauteries available. And the one which I use does not have a cutting and coag pedal. The same pedal can cut and coagulate if I can control the movements with my handpiece. So if I take a large amount of tissue, it is going to coagulate. If I take the tip of the tissue, tissue with the tip of my grasper, it is going to give me a cutting effect. So we have to understand the principles of electrosurgery, and if they are applied to your bipolar, it becomes a cutting device. So obviously, the lateral thermal spread is far more. And in areas where you are going to be close to the ureter or the bowel, I would not want to use, or adhesiolysis, I would not use a shearer. I would probably use a cold scissors rather than use a bipolar scissors if harmonic is not available. If harmonic is available, obviously, that's a good choice of equipment. But I think the whole surgery becomes extremely cheap in our country if you are going to use a reusable standard bipolar shearer for most of your major surgeries.
Yes, sir. So basically the tissue effects depends on variables like the power setting, the electrical waveform, that are whether it is continuous. So continuous brings about cutting, and the configuration of the electrode. So as sir already said, that a smaller surface area will cause more of the cutting effect than a larger surface area, which will bring about the coagulation effect. And I also lateral thermal spread depends on the time of for how much you apply the energy. So the longer you keep pressing the pedal, the more lateral thermal spread, even after the desiccation of the tissues, especially. Once the tissues are desiccated and you go on applying energy, it is going to cause lateral thermal spread.
So
So
one more word.
only comment is with regards to shearer. As a simple observer, I have observed that it is one of the device which has a maximum lateral thermal spread, and I think that is the only biggest worry that I have while using that. And secondly, I want to just highlight that Indian Medical Device Regulation Act is very active now, and we need to know that which devices that we are using, whether they are registered under IMDR or not, because in case of any trouble or any such complications, the only thing which will be looked at is not whether it is even FDA recognized or not, but IMDR certification is most important. So I don't know whether which of these shearers or which of these devices have been regulated or registered into that. I think this is one important thing which we need to understand.
So as one more word I will add, Pranay sir just said the second part of the thing. Basically, the cutting effect with the shearer is that the cutting, when you press the yellow on the shearer mode, there is a pulsed high voltage that comes. It's not like the blue of the coag, this thing that there is it's just for a very, the circuit automatically turns off. That is what they have explained me. And the second is the modified tip. Now, similarly, I have had the opportunity to use, just for demo, that Bissinger company only bipolar that Suyash showed. Yeah, so I have used it twice in hysterectomies, and it works fantastically. It's very expensive, but the tip is so sleek, and I don't know how many cases will the hand probe last, but it is superb with a white cut. So again, I've only used it twice for
Dr.
demo.
Shenjini, does it give a beep? I mean, with what?
No,
Yes,
no.
are you
There is no
using it?
signal. There is no signal. There is this. It basically works like the shearer only. You have to know when to make that one movement to just snip it.
Okay.
And
May I make a comment, sir?
Yes, please do.
So, sir, I have been using the shearer for about 8-9 years now, along with the harmonic, and 95% of cases, any case, I am quite happy with using the shearer alone. Previously, the ESU which was available had only one pedal where you had to modulate the effect on the tissue by the sweeping action of your hand, in which if you stay on the tissue for a long time, it will coagulate, and if you sweep with the blade, it will cut. Now, with dedicated pedals for coagulation and cutting, exactly as Dr. Shinjini mentioned, the peak voltage is achieved before the resistance of the tissue is overcome. So that leads to explosion intracellular and the tissues desiccate. If you, just for the purpose of demonstration, if you use it in a case of hysterectomy sometimes, and you see the effect when you're doing let's say a salpingectomy before a hysterectomy, and you try to use the coag pedal, that means the seal pedal on one tube and the cut pedal on the other tube, you will yourself be able to see the difference of the massive lateral spread which occurs in the seal mode, but almost nil lateral spread which occurs in the cut mode. So I would recommend that instead of being judgmental about the device as to whether it is dangerous or not, if we can just assume that the device is like a bipolar, and we during our surgery exert all the precautions that we would exert while using a bipolar cautery in our hand, then it is definitely very safe. Even if we are using harmonic, we are not going to dissect any less. So I'm sure all of us, once we become more and more better in our dissection, are going to create a good plane of separation between the vital structure and the surrounding organ, no matter which energy source we use. So in that sense, in the cut mode and placed at a very slight stretch and on the pure cutting mode, which is not the seal mode, the cut mode of the of the shearer, it cuts instantly, and that too with some of the new modifications which some of our colleagues have made. The effect on the tissue is really smooth, and I would say it is comparable to anything else available in the market.
Yes, so basically it is user dependent as well, as the ESU has to have the ability to have, or rather has a software in which the energy is delivered to the tissue in the desired way. So
Amaya, can I make a comment? Yeah. So I think when you compare these expensive devices like the harmonic ligature, they are actually more like a plug and play, where your learning curve is very short as compared to a little longer learning curve for the bipolar shearer. It definitely
Much longer. Absolutely.
it definitely needs a learning. Whereas harmonic and ligature and NCL are plug and play. You see two or three cases and you are ready to start doing the things.
Yeah.
Sir, one question to, Pranay sir, Amay sir, Sanke, anybody can answer. When you talk about shearer, can you say that all the shearers that are available on the market have same performance, same efficiency, and this thing? Can you put them in the same box, same classification?
Suyesh, just like all the surgeons available in the city and country are not same, the equipment is different and there is different. So if somebody is a good surgeon, they will use it well. If they are not good surgeons, they'll keep on saying that this is bad and all equipment for them is bad. So I think you have to be judicious.
Okay, thank you.
Okay. See, there is the next question I would like to put to this panel is, I have seen on the media as well, there's a revival of a lot of fistula repairs. So my understanding of the development of fistulas is like, are the newer devices responsible for this unnoticed damage which is leading to fistulas? Means I would like to have your opinion on it.
My opinion, frankly, is that your short training courses of 10 cases, making people into advanced laparoscopic surgeons, is the one which is the main reason why so many fistulas are created. And I was a party to, one of surgeons like that who bragged that in my town thing, in the last 1 month, we had 4 fistulas. My urologist came and repaired them. I said, this is not something which I would brag about. So I think there's somewhere apart from the instrument, obviously the instrument may play a role, but it is an inadequate training of how to perform the advanced surgery, which goes a long way in creating this complication.
Identifying different tissue planes and knowing the anatomy well is very essential, I suppose.
No. So that comes with your experience.
Yes.
When you have a junior person going in for endoscopic surgery, I know most of the people have not even seen an abdominal hysterectomy before they start doing a lap hysterectomy. Unfortunately, in a medical colleges. So when they do it, it's a different ball game as compared to somebody who's in 20 years of practice, then goes into laparoscopy. I think that's the difference.
Yeah. So I would like to make a comment on this as well. See, basically, when we use any modality, maybe monopolar, bipolar, or ultrasonic, we see a visible tissue effect. But we do not see the tissue effect which happens adjacent to this tissue. Like Dr. Sanket highlighted that the lateral spread can be controlled by modifying the tip of the instrument. So basically, we are not aware of the tissue effect or the depth of penetration. So an important factor of usage by the surgeon as to amount of tissue dwell time, the way he delivers the energy, that makes a big difference. And we should be aware that when we have to use it near vital structures, either you go to cold scissors or you dissect more and you cut less or you seal less. So it is knowing the anatomical planes, dissecting, keeping the tissue away is very, very crucial in this. Because, and one more important thing is we should use judiciously the mechanical modalities as well, such as clip applicators or suturing certain vessels, especially when you're doing the ureteric tunnel. You can put the clips on these veins in the bladder pillar, which can, like when you want to de-roof the ureteric tunnel, it is judicious not to use the energy and use cold cuts and using mechanical devices for appropriate outcome. Another question which I would like to post to this panel is, I have seen some surgeons show in the seminars, they use irrigation of the tissue. Means after using the energy on the tissue, they are irrigating it with saline. So if anybody could explain the use of this cold saline and how it helps in, getting better tissue effect thereafter. Anybody can answer this?
So basically, when you irrigate a tissue, you keep lowering down the temperature of the tissue, and the superficial charring that happens is minimized. So superficial charring makes the energy spread laterally rather than penetrate the depth. And because the blood flows through the vessel. So for example, if we are talking of uterine artery at the level of internal os when we are doing a hysterectomy, so if you keep pressing, even if you're using standardized instruments, I'm not talking of the tissue ligashore type of devices, but if you're using a standard bipolar and you keep wetting the environment, you will be able to create a deeper seal. Because the heat normally, the blood carries away as the blood flows through the vessel. So the first basis of any hemostasis is to stop the flow of the blood. The second is to give a little pressure. The pressure is the second mechanism. The third is the heat. So as the superficial layers of the adventitia so basically standard bipolars act by thrombus formation. You need to have a thrombus to seal the so-called stop the vessel. So for a perfect thrombus to come, the coagulum should be uniform through the thickness. If you are cooling it down, it's like heating the roti on the low flame, and you get a complete this thing. So even I have tried it many times. We irrigate a little bit, especially when we feel that the external surface becomes a little too charry or a little too sticky. You just put in a wash of saline and then clamp the pedal. It works better. So there's no harm in doing that. It is actually a good technique.
So Dr. Amaya, saying what Sinjini explained is one part, that you want to cool down the tissue and reduce the temperature. The second part is that as the tissue gets dehydrated or desiccated, the tissue impedance increases. And to reduce the tissue impedance again, because the tissue impedance is what is going to decide how the current is going to flow. If the tissue impedance is low, the current is going to flow through the tissue between the two blades of the bipolar. If your tissue impedance increases, it is going to create lateral thermal spread. So every time you feel that the tissue is desiccated, but you are not confident that the vessel could have been sealed well, if you cool the tissue and you hydrate the tissue impedance is going to go down. Your bipolar is again going to flow through the tissue as it was flowing better. And if you do that 2 or 3 times, then you have a better chance of a perfect seal, even if your generator is not of very high quality. So even the cheaper generators, you can get a good bipolar seal by repeating this, and that is where a lot of people would use saline to cool the tissue and to reduce the tissue impedance.
Yes.
So I know of a surgeon who keeps a little fluid in the POD and keeps dipping the tip of the jaws of the bipolar, and then again. So it's the same thing, basically, it works.
Amaya, I think if you, about 10 years back, Ethicon used to come with disposable monopolar hooks and spatulas, which were hollow, and you can actually irrigate the tissue. I mean, those are not, unfortunately, not available now, but those were hollow, and you could push in saline while we are using monopolar to keep on decreasing the temperature and hydrate. I mean, they are off the market, but Ethicon used to sell these, disposable monopolar spatulas and hooks with hollow where saline could be pushed.
Sir, I think probably these smart bipolars which can measure the impedance and accordingly modulate the current have obviated the needs of, this kind of irrigation and these surgical hacks probably.
I think, Suyash, what we need to understand is financially, how many of us can really afford to use the smart bipolars, because the bulk of the surgeries in our country are not done by the smart instruments. And people make a mistake of using a standard bipolar the way Ligashore and Harmonic is used and pay the price for it. So I think you need to have a very good distinction that, no, I don't have a smart instrument, but as a smart surgeon, I can use it in a better way rather than saying that I didn't do a good surgery because Harmonic or Ligashore is not available.
Okay. So now one more question. I think this is to Dr. Sanket. In your presentation, Dr. Sanket, you mentioned that the tissue effect caused by the ultrasonic energy is at a lower temperature. Could you, elaborate more on that? As is vis-a-vis when you compare the tip of the instrument when you're using monopolar energy or bipolar energy or the smart bipolars, as Dr. Suyash highlighted, that they get cut off at a temperature of 100 degrees Celsius. So what is the temperature which is achieved by the tip of the harmonic when it causes its thermal tissue effect?
The tip of the harmonic actually probably achieves a higher temperature than the standard bipolar. So I think, to the best of my knowledge, it goes above 100 degrees centigrade. But because the clamping action is there in between the jaws of the tissue, the overall amount of energy required to seal or to cut is a little less, and therefore the lateral spread is also less and the cut effect is better. But if we talk of the physical temperature of the tip of the harmonic, then I'm not sure how many in degrees, but to my knowledge, it goes higher than the tip of the bipolar.
Yeah.
Can I just take a call on that? One brief listening. So basically, harmonic cuts at lower temperature. That is true. In fact, the cutting happens at around 80 degrees centigrade. It is not 100. Normally, agar hum 100 pe, the cellular water evaporates and the cell bursts. So to us as a surgeon, the bursting of the cell is seen as a cutting effect on the tissue. That all of us know. Now, how the harmonic acts is by creating a vibration at the level of the tissue where the tip vibrates very fast. So there is a law in physics that when you vibrate at a very fast frequency, you create a zone of low pressure in the surrounding environment. Now, low pressure, water boils faster. There was a question in 10th class physics, कि mountain पे जाते हैं तो चाय जल्दी क्यों बन जाती है? Because see, if you all answered that question, we used to answer the atmospheric pressure at the mountain is lower and therefore water boils more quickly. This is what happens. So the cellular water in a zone of lower pressure, in that local zone of lower pressure, boils at 80 degrees rather than 100 degrees and you cut the tissue. So this is how the harmonic is by default a safer instrument in a situation which is as close to the ureter as possible. So when you're doing endo and you're using it to take the deep endometriosis out, you are by default way more safer. The number of seconds for which it is used, that is the tip temperature, that is very high. For example, if you use the harmonic for maybe 5 seconds and retract the bowel with it by mistake, you will immediately notice that the bowel blanches out. In fact, the temperature, it is said, goes as high as 200 degrees centigrade at the tip after a continuous activation of 5 to 8 seconds. But that doesn't percolate to the tissue cutting. Tissue cutting is via different phenomena. It is at sub 100, which is at 80 degrees. Exactly.
Yeah. So when I was preparing for this webinar, I came across this paper in which they calibrated or they checked the temperatures of the tips.
Yes.
When it was compared, the monopolars did the effect at 100.1 degrees Celsius. The bipolars and the modified bipolars did it at 50 degrees Celsius. The harmonic scalpel did it at 76.1 degrees Celsius. Ligashore did it at 100 degrees Celsius. So all these tell us that the lesser the temperature you do the tissue cutting, better is the effect. So it is dependent on the instrument calibration. That is where Dr. Suyash's comment on IMDR regulations and specification is important. And the second factor is the usage by the surgeon. So the magic lies in the magician, not the wand. That is what I want to highlight in this. Coming to the next question is, how much time is required for the heated tip of your energy source to come down to a temperature when it can cause no damage? So there are studies which said that the tissue damage is not incurred until a temperature of 42 degrees Celsius. So my question is, how much time is required before the temperature of the tip of your instrument comes down to this safe limit? So I would like to have your comments on that. So that will tell us how you use the instrument without causing unintentional injury to tissue. No comment?
I think one is understanding the critical zone. What has been studied is that between 40 to 50 degrees Celsius, you have the zone where you can damage the tissues irreversibly, and there cannot be any, I mean, that is what the thermal damage to ureter or
that is that 42 degrees up to after which that permanent damage is caused.
So for the tip to come down to up, less than 40 degrees Celsius, it depends on different devices. I mean, bipolar has got so many varied devices, and the problem with so many devices is that every device has different surface characteristics. And if you just look at the insulation also, then every company will have a different kind of insulation, and all these things are important to consider. But in general, we should be at least be waiting 5 to 7 seconds before catching any important structure with the same bipolar or with the same device which we have just used for sealing.
Yeah. So the critical time is about 8 seconds, to be very precise, until which you can hold the tissue again. See, again, coming to this temperature business, monopolar is the last to cool down. Remember that when you use monopolar energy, it takes 55 seconds to come down to 42 degrees Celsius. Ligashore comes down in 14 seconds, and the harmonic comes down in 20 seconds. The bipolars are in between, so they swing around something like 22 seconds or 24 seconds. So it is very important to use or understand the physics of your instrument before using it on the tissue to have a cutting or a coagulating or whatever desired effect.
I think the important thing is not to use any of these energy sources as a retractor. Because quite often what we do is after we have cut a particular tissue, if the bowel or omentum is coming, we try to retract it with the energy source. That is something which we should completely avoid. Use a non-energy source instrument to retract tissue so that you never have this problem. I think if you get into this good surgical habit, we'll never have a problem with the energy source.
Yes, that is very important, and having good retraction of tissues, guarding them with appropriate instrumentation should be exercised. One should not be hesitant about using an extra port if the viscous is coming in your way. Very, very important. One last question, sir. You spoke to us about lasers. So you did in your last slide mention about the hazards of laser. So could you tell us what are the hazards of laser and why that? I think probably that is why it has not caught up in clinical practice in a big way.
No, I think Dr. Kulkarni already mentioned in the presentation that the hazard is there only if the laser is kept active. So whenever you are not using the laser on the tissue, the machine can be immediately put on the standby mode. So if you are able to do that and you activate the laser or fire the laser only at the time when you want to treat the tissue, then the lasers are safe. The problem is with lasers being exposed when either they are out of the body, or we know that lasers can be reflected. So if you are doing an open surgery, even if the laser is beam is being directed to the abdomen, it can get reflected and going to the eye. So I think in laparoscopic or minimal access surgery or hysteroscopy, lasers are very safe because we are anyway working in a concealed cavity. The laser exposure would be important if you are using it for open surgery, because then the laser can get exposed and we know that it is a light can get reflected. And if that reflected light goes into my eyes, I can get laser burns. So that is why eyewear is required. But if you see, even in my initial part, when I saw a lot of lasers being used in laparoscopic surgery, I don't think lasers are as harmful if you do not activate the laser while the fiber is in the abdomen and you are just going to touch the tissue. The moment you finish your job, the machine should go on a standby mode and they are safe. Lasers would be, dangerous if I am using it for, open surgery or like for, cervical erosions or CIN, where if I'm using in the vagina, the light can get reflected onto me, right? Because the vaginal zinc light can get reflected into the eye of the surgeon and then protective eyewear is. So I think in minimal invasive surgery, we should not be worried about that. I think it was mainly the high cost and a new generation of safer equipment coming, which were far cheaper, because today, if you see, most of our equipment are in the range of 8 to 10 lakhs and lasers start from 25 lakhs and above. So I think there's a huge jump, and the lasers, if you in my presentation, we know that the main application is only for endometriosis. So how many people are doing purely endometriosis surgeries? Because your other instruments are going to be used in a large gamut of surgeries as compared to that. So I think that's why lasers have not been used, but they are safe if you understand the physics.
The laser
putting the
can
machine
be hazardous, and that is why it needs to be sucked out through the suction tube.
Okay, so
that I already mentioned, that viral particles can be there.
They can.
Yeah, so that can be sucked out, but more importantly is the.
You mean open and laparoscopic?
Yes.
Yeah, so
this putting the machine on standby mode is in the surgeon's control, or some external person has to only do it?
No, the OT assistant.
No, even we can do it. I mean, basically, if your foot switches, you don't press it, it'll go in the standby mode.
That is different. You have to put the machine on the standby mode, and pressing the foot switch is like using the pedal of the cautery. But then the making the machine ready and putting it on standby mode is done by the OT assistants usually.
No. So yes, what you need to understand is, till the fiber is in the abdomen, even if it is not on the standby mode, it is safe. It is only when the laser fiber is
switched.
Yeah.
Okay.
No, even for even for lap surgery, because if my fiber is going through a 5 millimeter cannula and it is in the abdomen, the light cannot go into my eyes. It is only if I remove the bare fiber outside and it is active, then it can affect me or the OT people. So that way laser is safe in minimal access.
If it is not on the standby mode and you inadvertently press the pedal, so it is likely to misfire.
Yeah, understood. So basically it is the lasers can be harmful and you need to be keeping them in standby mode when not used. Maybe the use of a smoke evacuation system may aid in reducing the aerosol menace of lasers.
Amay, I think if the lasers come back, you will earn a lot of money, because with your smoke evacuator, I think you will become very rich.
Yeah, thank you.
Amay sir, I wanted to ask this question. Your Pranay sir mentioned that, in the laser plume, the viral DNA has been, and the papilloma virus has been identified. What about the fumes created by cautery and harmonic? Can that even have viral particles, or virus can be detected?
In fact, the particles which are formed with the use of ultrasonic energy, they are larger particles. So they can be good vehicles for transmission of biological agents, bacteria.
That is why during the COVID-19 era, we started using the smoke evacuator.
Exactly. So that is what we were coming to, that the use of smoke evacuation systems with all these advanced energy sources is an essential part of the armamentarium for all surgeries.
One question to Shinjini.
Yes, sir.
During your presentation, you mentioned that this coagulating current is more injurious. So should now we only use the cutting current for coagulation?
Yes, sir. Actually, the yellow pedal is the safest in terms of doing the entire surgery. Only thing, we don't have even if you notice, if you're doing a C-section and there is a rectus muscle bleed,
Yeah.
by default, we are taught by our seniors because we always see our seniors and mimic them.
Yeah,
See
we
the
use
surgery.
blue pedal.
But you try using the yellow. Only thing, there has to be a patience. It takes time to set the seal, but you will not have to buzz twice. But chota vessel to वैसे ही it crackles and sets.
Yeah.
But bade vessels, it is always a more in the Western world, no one uses the blue to cut major surgeries.
Yeah,
Everyone uses the
absolutely.
yellow.
Dr. Pandit, if I was the manufacturer, I'll take off the blue pedal. I'll just have a single yellow pedal. There's no need for the blue pedal.
You should go
In
ahead.
fact, sir, one word, lot of us do that cervical erosion के लिए, that roller ball से हम blue पे जला के cervix को रात कर देते हैं. You just try using the yellow pedal. If your students or anyone just tries the yellow pedal on that, it's a white, perfect coagulum that forms on the cervical erosion area. It's just an example. Otherwise, you keep rubbing on the green sheet to clear your eschar and then again buzz the cervix. Here you don't have to even think once.
It is very important to have the temperature of the tissue at your pre-decided level. So when you're seeing black tissue, you're actually overdoing or overusing your energy. Remember that. You're charring the tissue. So if you see black, you have overdone your electrosurgery. So you have to optimize it, and using the continuous waveform is an alternative or the solution for that. So Dr. Pandit, any comments before we conclude or have the concluding remarks for this session?
Yeah, I think today we had a very good discussion, and we learn a lot from our faculties. Almost all our doubts are cleared. Only one thing, as a beginner, sir, which instrument the beginner, suppose he has taken adequate endoscopy training and now he has some budgetary constraint also. So which single energy source he should buy and start doing laparoscopic hysterectomy?
Bipolar.
Bipolar and scissors.
Bipolar and scissors, absolutely. The bipolar is irreplaceable. After the bipolar, you can add on, but not do away with
it. Basic.
Yeah, Dr. Pandit, I think what is not adequately stressed in teaching is the role of mastering suturing before you do any of these things. Suturing is always a good fallback when any of your energy sources fail. So, a lot of people are taught that you don't need to learn suturing because ligature and harmonic, will seal and cut 7 millimeter vessels. But I think we need to master suturing, because then we are confident that on a particular day, if your ligature or anything else fails, suturing can, save the day for us.
Yeah, that's why we tell no, suture is the future in endoscopy.
Absolutely, sir. So before we can have the vote of thanks by Dr. Kalyan, just final points to consolidate what we learned today. The discussion we had today culminates into the first inference that bipolar energy is the mainstay of every minimally invasive surgical unit. Use the bipolar energy in the continuous waveform. Use the lowest voltage or wattage which you can have effective tissue effect. Yeah. The tissue dwell time means the time which you deliver energy to the tissue should be shortest. Keep the tips of your instrument clean and free of eschar. Keep handy a cleaning solution with hydrogen peroxide and a brush. Read your product profile, know the physics of your energy source you want to use before using it. Keep your instruments dry. See, why I'm saying this? Because many bipolar instruments go bad because they are rinsed with saline, and that interface causes jumping of the current and burning or damage to the inserts. So keep them dry before you use them. Instruct your CSSG team to inspect the instruments on a regular basis for insulation failure. And of course, know your anatomy well, dissect more, burn less. Okay. So I hand over the stage to Dr. Kalyan for his concluding remarks.
I think I think all the experts have given such a good deliberation. I think what everybody wants is an instrument which will give maximum vessel burst, least thermal damage, least smoke, and fastest ceiling effect. That is what is important for all of us. So a right energy or right equipment use for right reason will ensure right results. That is what is the concluding remarks. And we are really thankful to President IAGE, Dr. Pandit Palaskar sir, for this opportunity. I thank Dr. Shinjini Pandey, Dr. Suyash Nawal, Dr. Sanket Pisat, Dr. Pranay Shah sir, and Dr. Anuja Kulkarni for such an excellent deliberation on energy sources in minimal invasive gynecology and solving all the queries and questions of the audience. That is very important part of this webinar, which everybody has liked, and I'm getting messages for that. I thank all IAG office bearers, executive members, and all IAG members for attending this webinar in large numbers. I thank Iowa division of Emcure for being an academic partner for this session. And next session or webinar will be on fibroids. That will be on 26th of August 2023. Stay tuned. Thank you for attending. Good night.
Thank you very much.
Thank you.
Thank you
Thank
all
you.
the faculty.
Thank you so much. Thank you
Thank you,
so
sir.
much.
Thank you, Dr. Pandit.
We
Efforts.
can
Thank you.
close. We can stop the recording.
Yeah. Thank you so much, sir. And thank you, Dr. Pandit Palaskar sir. Thank you, Dr. Kalyan Barande sir, and Dr. Padmar sir for giving us opportunity. And it was great academic week.